Good afternoon, everyone. Ladies and gentlemen, esteemed colleagues, fellow educators, and honorable guests. A very good afternoon to all of you. With the blessings of Honorable Founder President Dr. Ashok Chauhan sir, Honorable Chancellor Dr. Atul Chauhan sir, and under the guidance of Vice Chancellor Madam Dr. Balvinder Shukla, mentor of AIES, we, Natural Resources and Environmental Sciences domain, welcome all of you to this webinar on groundwater depletion in India, causes, implications, way forward for the sustainable practices. I am honored to stand before all of you today as we come together to shed light on one of the most pressing environmental challenges faced by our country. Before going further, I would start beginning by reciting a small poem on the same issue. भूतल में है जल सागर गहरा, पर्वत पर हिम बनकर ठहरा, बनकर मेघ वायुमंडल में घूम घूम कर देता पहरा, पानी बिन सब सून जगत में यह अनुपम धन है, जल पीकर जीते सब प्राणी, जल ही तो जीवन है। बादल अमृत सा जल लाता, अपने घर आंगन बरसाता, करते नहीं संग्रहण उसका, तब बह बहकर प्रलय मचाता, त्राही त्राही करता फिरता कितना मूर्ख मन है, जल पीकर जीते सब प्राणी, जल ही तो जीवन है। With those words, I would like to focus on some of the statistics. India, with its vast population and diverse geography, heavily relies on groundwater as a critical resource for agriculture, industry, and domestic use. However, the unsustainable extraction and mismanagement of groundwater have led to severe depletion levels in several regions. This crisis poses a significant threat to our food security, livelihoods of millions, and overall well-being of our nation. According to a report by the Composite Water Management Index, approximately 40% of India's population will have no access to the drinking water by year 2030 if groundwater continues to be depleted at the current rate. This statistic underscores the urgency and severity of the situation. Today, we have gathered a distinguished panel of experts, scientists, policymakers, and concerned citizens who share a common goal to explore the causes behind groundwater depletion, understand its implication, and chart a sustainable path forward. I encourage all the participants to please actively engage in this webinar, ask questions, and share your valuable experiences and expertise. Let us embark on this journey of knowledge, collaboration, and action. Thank you, and let's begin. So, for the foremost, we will begin with a lighting of lamp and Saraswati Vandana. I request my team to please play the same.
वाणी, हम भी तो समझे, हम भी तो जाने, विद्या का हमको अधिकार दे माँ, हे शारदे माँ, हे शारदे माँ, अज्ञानता से हमें तार दे माँ, हे शारदे माँ, हे शारदे माँ, अज्ञानता से हमें तार दे माँ, हे शारदे माँ, हे शारदे माँ, अज्ञानता से हमें तार दे माँ।
Thank you so much, team. That was definitely a blissful starting. So as we have already fulfilled our tradition of Saraswati Vandana, we will now invite Dr. Renu Dhupar, Assistant Director at AIES, to give us a welcome introduction.
Thank you, Dr. Juhi. Very good afternoon and namaskar to all. I, Dr. Renu Dhupar, extend my warm welcome on behalf of Natural Resource and Environmental Science Domain, Amity University, Noida, Uttar Pradesh, to greet and welcome to our honorable speakers, dignitaries, participants, my dear colleagues and staff members, to the webinar on Bhujal Saptah celebration on topic groundwater depletion in India, its causes, implications, and way forward to sustainable practices. It gives me immense pleasure to stand before you today and address this extreme gathering. Thank you all for taking out time and being present at this important event. Water security or scarcity is a pressing global concern, and India is no exception to this challenge. And water, as we all know, that water is a very precious resource that sustains life on our planet. And groundwater serves as a vital lifeline for communities across India. However, in recent years, due to the explosion of the population, we have witnessed a concerning trend towards the depletion of groundwater resourcing at an alarming rate, either due to chemical fertilizers, industries, and release of the toxic waste products from the industries and from the homes. And today we have gathered here virtually, representing diverse background, expertise, and experience to shed light on these pressing issues and explore the potential solution for sustainable groundwater management. In India, agriculture, industrial activities, and domestic consumption heavily rely on the groundwater resources. And unfortunately, all these unregulated extractions, improper irrigation techniques, and the rapid expansion of the urban areas have led to an imbalance in the groundwater cycle, which causes a severe depletion in various regions of the country. And the consequences of this depletion are far-reaching and affect both the environment and human well-being. And as we delve into the causes and implications of groundwater depletion, we will hear from the extreme experts and researchers who have been at the forefront of studying and understanding this crisis. Today, we will gain valuable insight into the challenges we will face for the groundwater depletion, its implications, and the management strategy, which is the need for action nowadays. On this occasion, it is an honor and privilege for us to welcome our Honorable Founder President, Sir Dr. Ashok Kumar Chauhan ji. And today we are able to conduct this webinar on this hot current topic, groundwater depletion, is only because of his constant moral support, blessing, and strength. He is a guiding force for us. My deep regards and thanks to respected Chancellor, Sir Dr. Atul Chauhan, Sir. It is his vision and leadership that has placed Amity University among the top universities in the world. I'm delighted to welcome our respected Vice Chancellor, Madam Professor Balvinder Shukla, ma'am. She's a guiding force for us, and with her support, motivation, and inspiration, we are able to plan this event. She's an excellent administrator who leads by example and who polishes each one of us and leads us towards excellence. I extend my warm welcome and regards to our eminent speakers, Dr. P.R. Ojasvi from ICAR, Indian Institute of Soil and Water Conservation, Dehradun, Dr. Gopal Krishnan, Scientist T, National Institute of Hydrology, Roorkee, Dr. Mukesh Anand, Scientist P, Central Groundwater Board, NCCR, Raipur, and Professor and Head, Dr. Brijesh Yadav from Department of Hydrology, IIT, Roorkee. Thank you, sir, for joining us and taking out your precious time to share your thought with us in this Amity platform on this time. And I thank you, sir, for accepting our invitation from a busy schedule, and warm welcome to all of you. The presence of such a personality in any function is a blessing for all the participants and for the students. We hope that the participants are able to seek a little guidance and imbibe something from their thoughts on this topic, groundwater, its depletion and management. Their guidance and their knowledge have been invaluable in shaping our understanding of this subject and discussed in inspiring us to push the boundaries of our own teaching practices. Welcome, sir. My warm greeting and welcome to Professor Dr. D.K. Bandyopadhyay, sir, Chief Advisor, Founder, President Office, and Chairperson, Amity Law School, and Mentor of Natural Resource and Environmental Science domain, for his continuous guidance and motivation always. I'm thankful for you, sir, for your kind support, suggestions, and guidance which you've given to us. And when we required, your guidance and mentorship have shaped the lives and careers of many. And we are eagerly anticipate the wisdom you will share with us in this platform. Welcome, sir. I would like to welcome Professor S.P. Singh, sir, Domain Head, and Professor Tanu Jindal, Domain Coordinator, for their endless support and help to execute this event. The objective of this webinar is not just to identify the issues, but also to foster a collaborative environment that encourages open dialogue and exchange of ideas. Only through these collective efforts, we are able to develop effective strategies to tackle this complex problem and move towards a sustainable water management practices. Remember that each region nowadays may have specific challenges and opportunities regarding groundwater management. Therefore, a customized and adaptive approach taking into the account of local conditions is very crucial for successful groundwater management. The involvement of the stakeholders and continuous monitoring and evaluation of management practices are key to achieving the sustainable groundwater use. Throughout this webinar, we will explore potential solutions, highlight successful case studies, and analyze the role of technology, policy frameworks, and community participation in conserving the groundwater resources. We will focus on seeking a way forward that empowers us to strike a balance between meeting the water needs of today without compromising the needs of future generation. I encourage each of you to actively participate in this discussion, share your valuable experience, and engage with the speakers and fellow attendees. Let us leverage the power of knowledge, innovation, and collaboration to create a sustainable future where every drop of groundwater is cherished and utilized very wisely. Before we proceed with the presentation discussion, I would like to extend my heartfelt appreciation and thanks to all the speakers, panelists, organizers, participants, and faculty members who have made this webinar possible. Your commitment to addressing these critical issues is commendable, and I am certain that your contribution will pave the way for positive challenge. Once again, thank you all of you for being a part of this webinar on groundwater conservation in India. Together, let us embark on this journey toward a water secure and sustainable future. Thank you. Over to Dr. Juhi.
Thank you so much, ma'am, for addressing all the speakers and welcoming them here on the panel. Now, I would request Dr. S.P. Singh, sir, Director ASNRSD, to give some opening remarks. Sir, you're on mute.
Thank you very much. It is my privilege to give an opening remarks on such an important issues, which is in the heart of everybody. Now, why we have taken this, why this has been started, even myself was not knowing there is the Bhujal Saptah, and I think this UP government has taken a special role, taking this program in each and every district to Blog and Tashla, and realizing that how badly we are going to be affected by these underground depletion problems. I just want to give a little brief about you that water is essential for sustained life. It is a limited resource, and we are required to use very judicially for the developing countries. Further, there are certain research has been made which says that million of drinking wells around the world are going to be soon dry. And it is also pointed out that 20% of the world groundwater wells may be facing imminent failure, potentially depriving million people of the fresh water. The situation is grim. Many part of India face acute water shortage at period every year. Depleting groundwater level have severe implication, spanning from water scarcity to gradual decline in agriculture production. Now, there are certain more fact has come, which is essential to tell about you, that it is estimated that
Hmm.
25% of rural and 50% of urban population are depending upon the groundwater. The India is the 17th countries which is having highest high water stress, and this is a report given by the World Resource Institutes. The Composite Waste Management Index to 1918 of Niti Aayog has said the water demand will exceed the supply by the 2050, and very interestingly that between 2002 to 2016 the water level is getting depleted at the rate of 10 to 25 per annum. In addition to this, that quality of water level is going down, but at the same time, quality of water is also getting worsened, having a lot of toxic materials. Now, think why it is happening. What are the main cause of that? Historically, if you see, that is the green revolution came to our country. We were having famine at that time. That green revolution bring this new variety of wheat, which require more water. In the country, places like Punjab, Haryana, all these places, we took out a lot of water because an insecticide or pesticide were used. And that is also, we have taken out more water. So excessive pumping of water from ground is really overdue the groundwater bank account. This groundwater is also just like a bank account, and that is been affected. The another problem is increasing population and development activities. And there are very important natural causes, uneven rainfall and the havoc of climate change. And this has also been aggravated by the doing a deforestation. So if you just see these is the basis, now what kind of impact we are going to get it? Number one, the lowering of water table leading to difficulty in extracting groundwater for usage. According to CGWB report, that 230 billion meter cubic of groundwater drawn every year for irrigation agriculture. Now we are doing very intensive agriculture. Earlier, this agriculture was substance agriculture. We are depending upon the rainwater. But now what we are doing, getting more production, and for that more productions, we are using a ground level. Everywhere you will find tube wells. This has been added by what? This has been added. Now it becomes all concessional, free, comparatively. So every farmers, irrespective of that, they are using more water and they are growing the crops which are requiring more water because of new varieties are coming up. So the cost of extraction is also going to be increases. And another thing which has come, contamination of groundwater has started. And now because we are going down to down, earlier we are having a fresh water available to us. Now when we are going down, then because of rock, the most of the places, if you take the example of Noida, Agra or Aligarh areas, where we certainly find the fresh water and sweet water, now this all become saline. In future, if we will not take care, then we will also face a problem of food supply because we need more food. So simply a traditional agriculture cannot help us for the purpose of things. There is also effect on biodiversities. And the very distinct thing is happening that we are creating a sinkholes. Is a earth. Earth is having inside of water. If you take it out, that may create a sinkhole, and that sinkholes can be very, very detrimental of very high rising buildings in our country. There are good examples, and there was also a newspaper reporting because of we are taking groundwater in a very, very high speed, and therefore the earth is also going to be tilted. And possibly this may be of the reason that our atmosphere is also changing uninterruptedly. It is despite of we are having such a flood rains and all that, most of the districts are still water stress. There is also seeing that there is a wide temporal spatial variation in the availability of water. And the interesting thing, groundwater is a common property resources. It is not individual. And that is also the reason that nobody is responsible. We are also required the legal status of groundwater, and the state government or the government of India has to take certain kind of restriction on this. And the very much low conscious. Nobody is knowing what is happening, how it is going to happen. So that is also there, and we are affecting the aquifers and our land use, land cover, our water resource availability are affecting. Now, these things are known, but what is to be done? So among the policy manager, there are various challenges as well. Crop pricing and water intensive crop. Can we ask the people that you stop doing a intensive crop and go for traditional? Can be in a position to feed the can supply the foods to everybody? And there are also techniques are available for estimation of groundwater resources. Yeah. Now, so I'm not going to a lot of government initiative have been taken up. I'm not going to the detail. I'm cutting my short this thing, but that will be spoken by the different persons and honorable vice chancellors there. They would like to address on this. So keeping this in mind, I'm cutting short my deliberations. So thank you very much for your time for listening. We will do it next year, full week program for this. This time we could not able to do because of very short notice. So we are arranging this on hybrid mode. Thank you very much.
Thank you so much, sir, for highlighting the alarming statistics. Obviously, that diverts our attention to the issue. Before inviting my next remarker, I would like to please address this issue that our first speaker is here available only for a very short time period, and we need to start by 3 p.m. for his talk. So please take care before addressing the audience. Now I would like to invite Professor Tanu Jindal, Director AITSM. Ma'am, please address the audience regarding the issue.
Okay. So with the blessings of Honorable Founder President, Dr. Ashok K. Chauhan, and respected mentor, Dr. D.K. Bandyopadhyay, respected Vice Chancellor, Dr. Balwinder Shukla, and our dynamic Chancellor, Dr. Atul Chauhan, we have gathered here today to celebrate Bhujal Saptah. It is a very important week which we need to celebrate in view of current scenario of water scarcity. In fact, water, I would also like to welcome our esteemed guest, Dr. P.R. Ojasvi, Dr. Gopal Krishna, Mr. Mukesh Anand, Professor Brijesh Yadav also. This is a very important topic because groundwater is being used by rural population for drinking purpose still in many parts of the India. And groundwater is also sometimes used in the urban area. In fact, we have carried out several studies on the groundwater with Ministry of Earth Sciences. And here we have studied how drains of Delhi are being contaminating the groundwater. This groundwater is contaminated because of the leaching of the open and unlined drains. These unlined drains are becoming the point of leaching of various kinds of contaminants. For example, there are different heavy metals which are being leached down. Then also there is difference between the coliform count and fecal coliform count, and many kinds of bacteria are also leaching down. These heavy metals are being leached down from the various industries and the effluents of various industries. These industries, generally they discharge their effluent into the drains directly. Therefore, this is becoming a very serious problem. As my previous speakers have already told about contamination of groundwater. In fact, CGWB, Central Groundwater Board, they have been analyzing certain parameters through piezometer about the quality on monthly basis. And but there are many parameters which are not being analyzed currently. For example, pesticides and heavy metals and other rare contaminants. So we have given recommendations that these drains should be made lime, concrete, so that these groundwater does not get contaminated. Then another project which we have carried out is on development of a lysimeter. So this lysimeter are the studies which are being done for the leaching studies. So here any kind of contaminant can be poured into the lysimeter and simulating the field conditions. Here we can study what kind of leaching is possible and how the leaching can be prevented. This lysimeter studies also can tell us how we can do bioremediation of any contaminant, and by simulating we can analyze the leachate and their contaminants. In fact, my camera was working just now. Somehow I don't know how this has happened. So I was just putting the backdrop. Also, there are large number of pesticides are being used in this country, and sometimes these pesticides are not used according to the given recommendations. So when the pesticides are being used double the recommended dose or more than the dose, in fact, whole pesticide leaches down. So we have given recommendation that for the pesticide dosages, the type of soil quality must be tested, and the recommendation of the dosage must be given according to the type of soil and also the formulation of a pesticide. For example, when it is a wettable powder or emulsifiable concentrate, they leach down more into the groundwater. While when there is a slow release control formulations, they leach down less. Also, there are certain conventional pesticides which leach down more, contaminating the groundwater. So we have also given recommendations for the use of new molecules, new pesticides, neonicotinoids, imidacloprid, synthetic pyrethroids, etc. for its usage. Also, we have carried out a project on contamination of groundwater through various pesticides used in vegetable, rice, and cotton growing area. Why we have taken vegetable, rice, and cotton growing area? Because maximum pesticide load is in cotton. And also then comes the rice and then comes the vegetables. So therefore, we have done these studies, and we have found that not only the rivers are getting contaminated by the excessive use of pesticides, but also many tube well samples are getting contaminated through these pesticides. So I would give that the groundwater is equally important, and its usage, it is only the 2% of the freshwater resource in all over the world, and its protection, its enhancement, and its conservation is very much important, as much population is still dependent on the freshwater resource. And I would now end my deliberation with few lines. As pure as water, as cool as water, as innocent as water, where is that meaning born? Proud of this planet is torn. Nectar of life to survive, soothes drink to revive, refreshing to take shard, having the life-generating power. It is exclusive to our green grove, first medium of life to evolve. Water brings civilizations in existence. It leaves behind all the cultural resistance. Therefore, we must now awake and arise. As groundwater level is sinking, seawater would be the only source to quench our thirst for our life discourse. Thank you so much, Juhi, for inviting me. And I will see why this camera is not working. And I'm looking forward to hear the deliberations of all other guests. Thank you so much.
Thank you so much, ma'am, for that beautiful poem. This would definitely ease all of us to begin properly. Now, I would request Professor D.K. Bandhopadhyay, Chief Advisor, FPO Chairman, MIT Law School, Mentor AIES, MIT University, Uttar Pradesh, to please address all of us on the topic.
Thank you, Juhi. Thank you very much. I see that all of you with your in charge of the MIT Institute of Environmental Studies, with the domain head Professor S.P. Singh, one after another, the most relevant, most topical, and most contemporary issues related to environments are getting discussed and getting elaborated and trying to find out what are the different policy interventions, what are the different scientific interventions can be made. And all my appreciation for AIES and the as such natural resource domain. All of you are working with the blessings of Honorable Founder President Dr. Ashok K. Chauhan and our Honorable Chancellor Dr. Atul Chauhan, and actually giving the impetus by our Honorable Vice Chancellor Dr. Balminder Shukla. Now I am very also happy to know that now we are Dr. P.R. Ojwasi and Dr. Gopal Krishnan and Dr. Mukesh Anand ji and Dr. Brijesh Jadhav ji. They are all present here to actually give us their views on the groundwater depletions in India. These groundwater depletions in India is a serious problem because India is home to 16% of the world population, but only holds 4% of the world's freshwater resources. And that is the statistics. 16% of the world population surviving only 4% of the freshwater resources. Not only is water scarce in India, but the extraction of groundwater has been on the rise for decades. Since the 1960s, the government support for green devolution to ensure food security has increased the demand for groundwater for agriculture. Rapid rural electrification combined with availability of the modern pump technology has led to an increase in the number of borewells to meet that demand. Over the last 50 years, the number of borewells has grown up from 1 million to 20 million, making India the most largest user of groundwater. The Central Groundwater Board of India estimates that about 17% of the groundwater blocks are overexploited, meaning the rate at which water is extracted exceeds the rate at which the aquifer is able to discharge, while 5% and 14% respectively are at critical and semi-critical stages. This situation is particularly alarming in three major regions: Northwestern, Western, and Southern Peninsular. Groundwater pollution and the effect of climate change, including erratic rainfall in the drier areas, put additional stress of groundwater resources, which serves about 80% of the domestic water supply in rural areas, 45% in urban areas, and about 60% of irrigated agriculture. Current overexploitation rate pose threats to livelihood, food security, climate-driven migration, sustainable poverty reduction, and urban development. The World Bank has been working with the Government of India to enhance groundwater management in affected areas. The lessons below stem from the experience of the World Bank groundwater management project in India and are part of the broader IEG evaluation of the World Bank support for sustainable and inclusive natural resource management. Now, integrated demand and supply side solution offer the best option for sustainable use. IEG case studies in Rajasthan, Telangana, and Andhra Pradesh showed that the success of supply side measures such as watershed management program, aquifer recharging, and tank rehabilitation activities did not lead to sustainable use in the absence of demand side action. Measures such as surface water harvesting through farm ponds and check dams, the installation of water efficient irrigation system, for example, efficient drips and sprinklers, and growing less water intensive crops need to be integrated on the demand side for improved management and reduced depletion. Now, weak regulatory action to limit demand for groundwater can hinder the success of programs in reversing groundwater depletion. So that's the most important thing. Weak regulatory action result in the expansion of groundwater, irrigated areas, and drilling of additional wells. This can more than affect water savings created by demand side measures or the water increases created by supply side measures, leading to further depletion. The government of India regulates groundwater exploitation in water states through notification of highly overexploited blocks that restrict development of the new groundwater structures, except those for drinking water. However, only about 14% of the overexploited blocks in the country are currently notified. Local level regulatory action in all threatened blocks before the such exploited stage is vital for avoid depletion. Now, strengthening community participation and right in groundwater governance can improve groundwater management. That is a new type of approach that is coming. How do we really strengthen the community participation? World Bank projects in peninsular India where more spread out and specifically defined hydrological sites prevail were successful on several fronts by implementing the participatory groundwater management approach, popularly known as PGM. The PGM approach empowers communities in a defined aquifer area, providing governance rights, community awareness, capacity development, and knowledge and motivation of social regulation and the implementation of the coordinated actions. Now, World Bank interventions support local institution capacity for groundwater governance, but such institutions are often not viable after the end of the project. Now, another interesting thing that has been happening, that power subsidies for pumping groundwater has accelerated the depletion of aquifer in stressed area. Several states affected by the depletion of groundwater provide free or heavily subsidized power, including solar pumps, for pumping groundwater for irrigated agriculture. This creates perverse incentives that enable our exploitation and depletion of scarce groundwater resources. In the long run, sustainable groundwater management will depend on cross-sectoral reforms to address the water energy agriculture nexus and providing the right incentive to resource users. This requires better coordination of policy makers, market regulators, as well as repursuing current distortive public support to more climate smart solution. Strengthening World Bank analytical support and investment in this direction would be useful for the future. So groundwater extraction has allowed rural families to reduce short-term vulnerability, but may incur trade-offs and increase the risk of depletion and ultimately increase vulnerability in the long run. However, without sufficient regulations or replacement of aquifer, the increased access to and use of groundwater for irrigation could lead to declining water tables and increasing water scarcity, which risk escalating long-term vulnerability. And this is the most important thing, that unless and until we have some policies in place, sometimes, and we don't have the cross-sectoral reforms that take place, how do we really shape our groundwater? How do we see that supply side of recharging the aquifer vis-a-vis the extract side that is needed for the benefit of the mankind, including agriculture, including food, and including the other requirement of the industry. So this demands different types of approaches, different types of policy interventions. And I think that is the reason Amity University, Uttar Pradesh, is actually celebrating groundwater depletion in India, causes, implication, and way forward. And way forward is the actually cross-sectoral approach. Now, once again, I thank in a natural resource domain and also thank AIES with the directions of the Honorable Vice Chancellor and with the blessings of Honorable Chancellor and Honorable Founder President, we are able to celebrate this within a short notice. And that actually exemplify the credibility and the capability of our natural resource domain. So thank you very much. Thank you Oja CB, Oja ji, Dr. Gopal Kishan ji, Dr. Mukesh Anand ji, Dr. Vijay Jadhav ji for coming over here within a short notice. So we are going to listen from you we are going to be educated by your deliberations. So thank you very much. Thank you once again.
Thank you, sir.
Thank you so much, sir, for addressing our speakers, for addressing all the audience regarding the issue. Next on my program, I will introduce someone who I have had the pleasure of knowing and hearing on several occasions. Today, I get the gracious opportunity to introduce her to the stage. She is the Vice Chancellor of AUP and is a PhD from Queen's University, UK. She has over 3 decades of rich scholarly experience in industry and academia. She is the Professor of Entrepreneurship, Leadership and IT and Vice Chancellor of MIT University. She has been one of the key team members, spearheading and instrumental in the exponential growth of MIT Group, engaged in higher education. Ma'am, who has been our guiding light, a source of continuous inspiration, is an excellent administrator who leads by example, who polishes each of us and leads us towards excellence. Ma'am, we have the privilege of hearing you earlier, and now, ladies and gentlemen, please join me in welcoming our Vice Chancellor, Madam Dr. Balwinder Shukla, to the dais. I'm really sorry for this. Our Vice Chancellor, Madam, is in a meeting and she'll be joining us shortly. So without further ado, and looking at the convenience of our speakers as well, I would like to introduce my first speaker, Dr. Gopal Krishnan. He is the Scientist D, Hydrological Investigation Division, National Institute of Hydrology, Roorkee. He is currently Scientist D at this institute and has been an ex-researcher in Indo-Gangetic Basin, Groundwater Resilience Project, British Geological Survey, United Kingdom. He has over 20 years of research experience in many facets of hydrological evaluations, surface water, and groundwater hydrology project management. Dr. Gopal has expertise in isotope hydrology, hydrogeochemistry, and water quality studies. He has supervised many PhD theses, many master dissertations, and also has been supervising one C.V. Raman Fellow and a DART Fellow. He has published more than 100 international journal articles. We would like to welcome you, sir, with a virtual Tulsi sapling, and we would like to invite you to the dais. Dr. Balwinder Shukla, Madam, is presenting the virtual sapling.
ये वाला zoom करना था.
Gopal, sir.
Hello, Juhi.
Hanji, ma'am.
Yeah, my camera is now on, in fact.
Yeah, it's working well, ma'am.
Yeah, I just wanted to say that, I'm looking forward to hear other deliberations. Thank you so much.
Gopal, sir.
Yes. Am I audible, please? Hello?
Yes, sir, you are audible.
My screen is visible?
Yes, sir, it is.
Oh, thank you, Dr. Juhi, for the nice introduction. And good afternoon to all. As my previous speakers has already informed you about the groundwater issues of India and the importance of the groundwater. So today I will be talking on the isotope applications for groundwater recharge estimation. So the contents of my talk will be introduction, need for recharge estimation, environmental traces, use of isotopes in water resource management, recharge estimation, and a few case studies. So first of all, I will start with the hydrological cycle. In hydrological cycle, so as we see, for this cycle, the sun is the main driver, where the water from the ocean is evaporated and just excuse me, important. So the water gets evaporated, and after its condensation, it falls on the earth in the form of precipitation. And when it falls on the earth in the form of precipitation, so this precipitated water either goes down in the form, it forms the groundwater, or is a runoff, or it meets with it conferences with the other rivers, or it's ultimately go to the ocean. So that if we see the distribution of this water, so we can see here the total estimated water 1.39 billion cubic kilometer. Out of this, 19.74 water is not usable. That is saline water in ocean. and the only 2.6% of it is the fresh water. And from this 2.6%, groundwater is 0.76% and ice and glacier 7.674%. And still these are not utilized. So water from these glaciers in the form of snow melt forms the rivers, and this river is constitutes only 0.002%. So you can see here, still groundwater has the largest fraction. That's why it's called the largest storage of the fresh water on the earth. So if you see the global scenario, you can see here India, groundwater dependency is increasing, and India is one of the hotspots. So in one of the studies we have carried out with the British Geological Survey for the Indo-Gangetic Basin, where we have found that the total volume of groundwater is about 30,000 cubic kilometer in the Indo-Gangetic Basin. UP is also the part of it, and about 20 times the combined annual flow in Ganges, Indus, and Brahmaputra. So, however, as estimated, previous speakers has also told about the groundwater quantity along with the groundwater quality. So, there are serious issues. 23% of this is saline, and 37% is affected by the arsenic, mainly in the eastern part of India. So, if you see, then we have also carried out a study where we have found that the century of groundwater accumulation, groundwater behavior, how it changes in the 1 century. So up to 1960, we found that there was the ample groundwater in this part, but it got declining after the introduction of the Green Revolution. So the groundwater had it was stabilized up to the 1990, and previous speakers have told that the number of groundwater structures has increased during the last few decades. So due to that, more of the groundwater has been extracted and leads to the groundwater depletion. So this is the CGWB part, where you can see the various blocks of the CGWB, and some most of them are about 1,114 are overexploited, and semi-critical are 1,057. Out of this, 1% is saline, and only 2,427 are safe. So if you see the groundwater decline, so groundwater decline, if it's quantified, it may be the 0 to 2 meter, 2 to 4 meter, or more than, sometimes it is 4 meter. So more than 60% of the assessment units in this part, Punjab, Haryana, Delhi, and Rajasthan, are either overexploited or in the critical regions. So if you see because rainfall is the only recharging source for this groundwater. So, but the groundwater rainfall is mainly this in the more than 70% during the monsoon period. So if you see the southwest monsoon, this constitutes the major source of water on this part. So if you see the methods for the estimating the groundwater recharge, how much this water has recharged the groundwater. So there were some conventional methods like soil water balance method, water table fluctuation method, then recession curve displacement method, and water level data. And if you see the equations for these, so these are some contemporary and conventional equations where you can see the water level of the final stages and initial stages, and then we multiplying with the precipitation and calculating the recharge, and they also finding the recharge through the precipitation minus evapotranspiration and storage and the runoff. So we are taking all these parameters into the one for finding the groundwater recharge. But there are some shortcomings of these methods. These methods don't assume to be the seepage from the wetted parameter of canals, or the constant factor for the infiltration rate is taken, and base flow to the surface water sources is not known, and the knowledge of specific yield and changes in water level over a time. So then other shortcomings are the recharge estimation by the water table fluctuation. So we can see here, we can find out how much groundwater has been recharged in the shallow wells, but we don't know how much water has gone from the shallow to the deeper wells. That's why we are using the environmental tracers. These tracers are a substance introduced into the biological organism or other system, so that its subsequent distribution may be readily followed from its color, radioactivity, or other distinctive property. So environmental tracers are ambient, natural, and man-made compounds widely distributed in the Earth's near surface. So may be injected naturally into the hydrological system from the atmosphere, or are added, lost, exchanged inherently as water flow over and through materials. So if you see the study of this is called isotope hydrology. Isotope hydrology is a rapidly emerging discipline where most of the involve difficulties and provide new insight into the concerned hydrological process. So we can use it as a supplement to the traditional hydrological evaluations. So it solves many of the problems. So if you see the what is the isotope hydrology, the basis for this suitable techniques for the groundwater recharge studies are because soil moisture movement in unsaturated zone. If you see the structure, first of all, the water will fall onto the earth surface. From there, it goes to the BDO zone or unsaturated zone. Then it forms the groundwater, which is the completely saturated zone. In unsaturated zone, stable hydrogen and oxygen isotopes and radioactive tritiums behave conservatively. So if it is conservative in nature, so it can be very much effectively used. So soil moisture evaporation. Also, the water gets evaporated from the soil moisture, which enriches due to the soil evaporation process. So these are some of the identification of the recharge sources of groundwater. It can also be done through the use of the isotopes and altitude of recharge area of springs in mountains area where there are no well-drilled aquifers. So in that condition, springs are there, and we can, using the isotope technique, we can find the altitude of the springs origins, and we can know the areas from where the springs can be recharged. So identification of recharge zone and discharge zones and flow rate. So we can use from the using the tritium dating techniques, area of modern groundwater or the old water, the spatial elevation of groundwater age can be used. Leaky aquifers, a break in increasing age trend reflects modern groundwater inflow from leaky aquifers. And then connate water. Sometimes the water is very old there, so we can use the carbon dating. In tritium dating, we can find up to the through 100 years, but for the very old water, we go for the convent dating, this carbon dating. So mixing of seawater with groundwater, some of the seawater intrusion is also there that we can also find using these techniques. So basically, this is some of the basis of suitability of these. So if you see here, so you can see this is the unsaturated zone, and from there, or widow zone, from the paddy field, vegetable field, sugar field, some of the water gets evaporated or it comes with the precipitation or irrigation water, then soil water retention, and then from the then it's to go to the groundwater where it is in the under the saturated conditions. So the isotopes are the say atoms of the same element with different number of neutrons and different mass. So you can see here O16, 8 electrons and 8 protons, 8 neutrons. But in O18, this number of neutrons has increased by the two numbers, but its abundance is less as compared to the O16. So here you can see when the number of neutrons are different, then it is the isotopes. When number of protons are different, then it is the isobars, and when isobars, and when there are the same number of neutrons and protons, but the element is not same, then it is called the isotones. So here the isotopes, same number of protons, but different number of neutrons. You can see here 16 and 18 numbers, hydrogen, deuterium, and your tritium. And then vibrational motions, molecules with lighter isotopes are more reactive. Isotopes effects are differences in physical and chemical properties. So you can see here these are stable isotopes, H1 and H2. H3 is your radioactive isotopes. I will tell you the definitions of the stable and radioactive isotopes. Here you can see water is not of one type. So it gives you signatures or like your fingerprinting. Different type of waters are there. The water structure is a HHO. So it may be your H1, H2 or O16, H1, H1 or O17, H1, O18. So there are, you can see 18 types of water can be found, and their relative abundance is found here. The 99% is your H1, O16 type. And it is found in the its delta notation. Its concentration is in the sample or in the, then divided by the standard. So there are various references are your from the ocean water where it is 0. You can see O18 is 0, and from to the some ice sheet gist or other ice sheet evaporation. So Antarctic ice sheet precipitation. So these are some of the standards, and when multiplied, because it comes up to the 2 decimals, that's why we multiply to a 1000 and notified it in per mil. So heavy molecules have lower velocity, smaller corrosion frequency, slower rate of reactions, while heavier molecules, here heavier, this is the most heaviest one, and this is your lightest one. So we know that what is the heavy water and what is the lighter water. So we see the classification of isotopes. There are stable, unstable, and environmental isotopes. Stable isotopes are those that don't decay with time. Elements have stable isotopes are also available in Earth's atmosphere, and for most of the hydrological studies, environmentally actively occurring stable isotopes are used. And unstable isotopes, if you see here, these are radioactive. These certain type of radiations are emitted by these, like your alpha, beta, and gamma. They have some half-life, and they becomes stable. They keep on emitting the radiations until and unless they become the stable. So if you see the environmental isotopes, these may be your stable or radioactive, but these are the environment. These are available in the environment. These are already present in the environment. That's why they are called environmental isotopes. So very sophisticated instruments are available for measuring these environmental isotopes. These are not harmful at all. We need not to buy them or not to inject them, because nowadays if we inject an artificial isotopes or artificial tracer, we need to take the permission from Department of Atomic Energy. So we cannot use these tracers now. So these are some of the classification that you can see from his chart: stable, unstable, natural, environmental, and there are some artificial also. So artificial are the controlled, which can be made in the or developed in the laboratory. So these are uncontrolled when atomic weapons. So in 1960 bombing, what happens? Lot of tritium was released into the environment. Now there is chlorofluorocarbons also. We are using them as a tracers, which are found in the refrigerators now. So if you see the isotope fractionation, differential partitioning of isotope between the two compounds is under the equilibrium condition or under the non-equilibrium condition. In equilibrium condition, phase change, chemical transformation, isotope exchange, mineral solution or gas solution. When it is non-equilibrium, sudden temperature change or addition or removal of reaction. So differential partitioning of one of isotope over another or one side of the thermodynamic reaction or differential partitioning. So how it forms? From the cloud vapor, it comes in the form of rain, then or snow, either into the river or it forms the groundwater. From rain directly to the groundwater or from groundwater into the river as a base flow. Or here you can see, as I told you, the sun was the driver of this hydrological cycle. So sun is the main driver. So from the ocean water, when it is evaporated, so it has some different isotope signature. This has different isotope signature. So when we see here, you can see here the values changing. So these are depleting as they're moving away from the ocean. So this is called the continental effect or altitude effect or latitude effect. So the values are changing. On that basis, we can identify the value which is the source of water. From there, these are the instrument. This is the dual. These are present in our institute. Dual inlet isotope ratio mass spectrometer, and second one is a continuous flow isotope spectrometer. So here is the it is for the aging. Here we can do we can use krypton, chlorofluorocarbon, sulfur hexafluoride, or you can see here up to the 60 years or 70 years or 100 years we can use using the CFC and sulfur hexafluoride. For the old waters, we can use the you can see tritium helium combination or helium krypton combination. We can find the water up to the age of 10 raised to power 6 years through these carbon dating, or these dating techniques. So how, if you see the one tritium unit defined as the presence of one tritium in 10 raised to power 18 atoms of hydrogen. This tritium enters the hydrological cycle after oxidation, and you can see here one initial concentration is 2 to 8 TU and added 1.13 10 raised to power 9 TU in 1963. So presently it is decreasing. So if its concentration is less than TU, we call it submodern or submodern to modern. 5 to 15 TU is modern and 15 to is bomb tritium. So this is the bomb tritium means this is during this period. So that's why from this tritium activity we can find the age of the water. So for the you can see if it is more than 10 TU, we call it the water age is less than 20 years, and if it is less than 1 TU, then we say the water is more than 100 year or it is older than the 1000 year for the old groundwater. So this is one of the study carried out in Punjab where we found the water of all these types. So we found that these red ones are the very old water trapped in the some of the deeper aquifers, and these are the continuously recharging aquifers. So we can find out these recharge estimates using the and from this you can see the age is decreasing from here, increasing from here to here. So the water movement is here. So we can find this distance, and we can from if we measure we can measure the distance and we can measure the age or time taken. So we can find the velocity of the water in the groundwater aquifers. So this is the direction and the age rate. So if you see the application of the groundwater studies in isotope, soil moisture variation, source identification, recharge zone identification, groundwater pollution, groundwater flow velocity, surface water groundwater interaction, submarine groundwater discharge, recharge estimation, recharge effectiveness, and the methods which can use for recharging the estimation, nutrient probe methods. You must have heard about this tritium tagging technique, deuterium enrichment technique, and member mixing, surface water, groundwater interactions. So methods with some case studies where when these neutrons are released into the soil, so the hydrogen atom will decrease their movement in the surface or the soil surface. So from there we can, if the more of the hydrogen atoms are present, its movement will be set that slow. So from that measurement we can find out its value. So if you see these are the alpha, beta, and gamma radiations. So alpha has the more energy, but it cannot penetrate, as is your you can see here gamma radiations are highly penetrating. So we need lead to check these. So for then neutron probe, you can see here drilling of bore wells. Then we are putting these probes into these drills or these boreholes, and from there when I go, these are some of the method. I'm not going to read out all these because the time is short and only 5 minutes are remaining. So I am not going to read out this. So, but if you can see here, these are the some of how we are finding the movement of the water or recharge estimation. From the moisture we can take, we are collecting the sample, and where this peak is enlarging, we are finding that this is the recharging. So these are the recharging points on different dates. From these dates we can find out the moisture content and two profiles of the wetted region, and we can find out the estimated recharge with this. And then tritium tagging also, it is also very part of what belong to lowest radiotoxicity class and the low cost radioactive pressure. And the assumption is that it is moving the piston flow. Piston flow type is the fresh water layer is adding to the surface water layer, and it is no exchange or loss of gain of isotope during the flow. Here we can see we are putting the tritium here. These are the activities are these tritium curves are here. When it is spreading, this means peak broadening, their diffusion and dispersion. So it is irregularities in the water input. So we can find out this disbursement depth and the average volume of water. So from this we can find out, this is some schematic. Here the radius of this borehole, and this is the depth of the 80 centimeter, and this is the units. And the units of these are either curie. Curie is 3.7 into 10 raised to 9 becquerels. Becquerel is also one of the this unit for this tritium tagging. So you can hear these are the various methods for analysis of soil core, then displacement D method and the moisture. Then how this is the how, then multiplying it with the recharge, or then where P or this RE divided by P into 100 will give you the recharge. So these are some of the recharge estimates for the different areas calculated using these techniques. So these are the some other methods. These are the conventional methods, and our method is almost similar to them. So we can save this much of time because these are very specific, and for this these are more accurate. So then the stable isotope can also be used for the finding the groundwater recharge estimations. You can see here there are two methods: peak shift method and transient flow and transport modeling. So if you see in the peak shift method, we collect the groundwater sample and rainfall sample, estimate groundwater charge, then percentage of groundwater charge due to the rainfall. Using this formula, we can find out this. So peak shift method, you can say peak is shifting from this to this. So we can find using the formula of this, and we can find out the recharge. So for more details, you can take my email address or phone. If anybody is interested in the detail of these methodologies, so you can contact me. So these are the deuterium techniques. These are also the same. Deuterium is inserted in the soil, or it moves slowly down to the saturated zone from unsaturated zone, and we can find out those movements from the Z2 minus Z1, T2 minus T. This is the time taken. So this is the storage moisture content, and then you can find out the recharge. So these are some of the water content profiles in deuterium. So isotopes are very effective in finding the recharge of the you can see recharge in the groundwater. These are the various distributions of the water in the rainy season and non-rainy season. So transient flow and the transport modeling we can do using the these some of the equations can be used, and we can find out the accurate amount of water is recharged in the even this is the age dating formula which I have told you already, and we can also find the source of recharge. this is one of the study we carried out for Punjab government, where we found the canal is recharging, or river is recharging. So we found that in the shallow aquifers, it is the mostly canal, and in the deeper aquifers, it is recharged by the precipitations. So you can see here. So, and then we have constructed more than 160 piezometers there for the different network of piezometers in 3 districts, and we found the interactions in the aquifers using the isotopes. So these are the marginal interaction, good interactions, and we can also found from the contribution from the river to the groundwater, how much is the contribution of that water to this using the isotopes. So, and then is your Yamuna water contribution we found in the, we have carried out a study in Agra where we have found the Yamuna water contributions in the groundwater and the base flow contributions, then temperature in Yamuna, and this is the salinity understanding. One of the speaker has told about the salinity. So we found the salinity, how it is spreading in the Haryana region. This was the study carried out in Mewat area. So here you can see. And then the single vent dilution technique also we have done. So these are some of the techniques where we have then spring recharge. We have from Gomukh to the Haridwar. We have done this using the isotope techniques, and we can find from where the recharge is. These are the various steps for this methodology, and you can see the radon decay. From the radon, we can find out the fresh water, seawater intrusion, as well as the submarine groundwater discharge, and we have carried out study in the east coast of West Bengal and in Odisha and the West Bengal here. So these are some of the studies carried out, and this is the infiltration study. And so if anyone is interested, that contact me for the details here. So I will stop here because I have a meeting with the Joint Secretary, Ministry of Jal Shakti. So I would like to thank Dr. Deshpande, Dr. Vishnukumar from Vienna, and Mr. from our institute, and thanks to all funding for different studies carried out this. And I am also thankful to Dr. Juhi Gupta and Dr. Harshita Jain for inviting me to this forum. But due to the shortage of time, some 10 minutes or 10 minutes shortage, so I cannot go into the detail, and I am concluding here soon. So thank you very much.
Thank you so much, sir. That was definitely indeed some information to gather. Apart from that, I would definitely like to congratulate on the study area. The study area is really important. And additionally, I have a small question that this isotopic technique for estimating the change in groundwater level, do you have any approximate percentage that how much water recharge we can expect after following all these results?
Yes. No, it is not we can increase the recharge by using isotopes, but we can measure the recharge, how much water has recharged from the rainfall or river or canal. That can be done using the isotopes, but we cannot enhance the recharge using the isotopes. But we can find the potential zones. We can identify the potential zones of the recharge, and if we find the potential zones of recharge, then certainly that is going to help.
Okay, sir. Okay. I would definitely like to congratulate you, sir. The topic is definitely important and has shed light on a lot of main objectives for the current issue. Reenu ma'am, should we proceed further with the next speaker?
Yes, with next speaker, Dr. Ji. Thank you, Gopal sir. Thank you so much. Within very short time duration, you have accepted our invitation and give your valuable information on this platform. No doubt this your presentation, excellent presentation regarding the whole data about the groundwater management, how you are managing the groundwater. It's sir, it's my humble request, if you allow, sir, if it's a privilege, if you give the permission for our students to join your organization for internship and for dissertation.
Surely. You can write up to our director, and you can specify for what domain you want to work, the groundwater or using the environmental tracer techniques or isotope technique, anything. You can write this specifically to our director, and he will surely allow.
Thank you so much. Thank you, Gopal sir. Thank you so much.
Thank you, sir. Thank you so much for joining.
Thank you.
Everyone, now I would like to introduce my second speaker, Dr. P.R. Ojaswi. He's an MTech and PhD in Agriculture Engineering from IIT Kharagpur. He has joined Indian Council of Agricultural Research, New Delhi as scientist in 1986 and continued at various positions. Presently, he is posted as Principal Scientist at ICAR, Indian Institute of Soil and Water Conservation, Dehradun. He studied at Michigan State University, USA, and was also a visiting scientist at McGill University, Canada. He worked on several national and international research projects funded by agencies like ICAR, NWDB, DST, NATP, NAIP, and CIDA. Some of the major areas of expertise include rehabilitation of wastelands, watershed development, water harvesting, hydrological modeling, and software development. Artificial intelligence has also been an expertise area for him. He has strong linkages with different institutions and state government departments, including agriculture, forest, and soil conservation. We would like to welcome you, sir, with a virtual Tulsi sapling, and please address our audience. Dr. D.K. Bandyopadhyay, sir, is presenting a virtual Tulsi sapling to his speaker.
Yeah, thank you very much, MIT University organizers at MIT University, Dr. D.K. Bandyopadhyay, Dr. S.P. Singh, and Dr. Joy Gupta and Dr. Renu Dupar, and all others, of course.
Thank you, sir.
Thank you very much for inviting me on this very relevant topic. I'm going to speak on rainwater management for food security, because that is where most of the fresh water resources are used. So I'm just sharing the screen. So anyway, as I said, my topic is rainwater management for food security. And I will not start with the statistics of water resources in our country, because that was done long ago, and we are quoting same figure. About 35 years ago it was done, that assessment of how much surface water, how much groundwater resources are there. Mainly because assessing water resources is difficult. It was done at a country level scale in 1995. And since then, we came to know how much surface and groundwater resources are there. That's okay, but information is old, so I will not quote. But importance of water in food security can be ascertained by the fact that even if we harness all our freshwater resources for irrigation, only 55% area of the net cultivable land in our country, that is 142 million hectare, can be irrigated. The rest of the 45% will still remain rain-fed. And you know how variable our monsoon rainfalls are. So 45% of the production of very, very crucial crops like oil seeds, cotton, rain-fed rice, and even wheat, cereals, millets, they are grown under rain-fed condition because there are no irrigation facilities and they can be grown under rain-fed condition. But productivity levels we need to improve through rainwater management. So that is the objective, and that we are working. We are many cases successful. Technology adoption is at a very wide scale. That problem can be solved, but you know, it requires technology adoption requires certain capital investment, and government is trying hard to reach to each and every farmer that requires that kind of investment and adoption of technologies. So that is why we are focusing on rainwater management. One of the slides I showed, a water balance in general whether it is a micro watershed or a catchment or river basin, you will find that out of the 100% of precipitation that we receive, that is the only freshwater resources we receive on our land. Only 40% on the average, I'm saying, only 40% flows through our rivers and stream. And that is what is visible to us. The water is flowing, that is visible. So we try to utilize it for different purposes, making dams, barrage, reservoirs. All the investment is going on there. Plus, there is groundwater component that we can use through technology of tube well and all. 60% on the average remains invisible. That is on the landscape, overland flow, soil moisture, what we call green water, then runoff, and ultimately either evaporates or it is transpired by the vegetation. If we are growing crops, orchards, forests, that is useful utilization of green water. If we are not using it, it is evaporating, then it is not useful. So that is the crux of rainwater management or rainwater harvesting, water conservation, whatever you call it. And the amount is huge, as I said, 65%, 60% on the average. Only 40% is visible. So for utilization of that 60% of, yeah, the screen is here.
Yes, sir. Sir, am I on the right slide?
Third slide, please.
So this is the third slide. So is this one?
Third one. It's not scrolling. Enable editing, you have to do enable editing.
So is this fine?
The screen is not yet visible.
So it looks as if
Dr. Juhi, screen is not visible. I think there's some issue.
I get it. Actually, the internet is, yeah, ma'am, it's written on the screen that the internet bandwidth is quite low. I'll ask somebody else to reshare it. It's okay. So you can continue with the talk then.
Okay, so to utilize these visual freshwater resources that is flowing through our streams and streams, rivers, etc., we build reservoirs. But again, their major problem is siltation of reservoirs. Large reservoirs are okay, but smaller ones which are scattered and they cater to the specific use of domestic agricultural industrial use to a smaller population. I mean, large projects are there, but their domain is very specific. They cannot cater the needs of all the stakeholders. So their command area is defined. There people get benefit. But other than that, large number of farmers or villages are deprived of the benefits of large water reservoirs, water utilization projects. So we have to build reservoirs on a small scale. I mean, that is something like less than 1 million meter cube even 500 meter cube, 1,000, 5,000, depending upon how much runoff can be harvested at that location. But there is a problem of siltation. I've seen many small reservoirs silted up even after 5, 6 years of their construction. So that is one problem of surface water storage. So sometimes in 11th plan, it was decided that, okay, we have plenty number of surface water reservoirs. Let us, now it's visible?
Yes, now slides are visible, sir.
Yeah. So I was talking about this slide only.
Okay.
So siltation of smaller dams pose a serious threat because they serve to a water population for domestic agricultural and industrial purposes. So I have to call for next one. I cannot move it.
Mr. Naresh, please move to next slide.
Yeah, another thing that we have to consider as far as water sector is concerned, climate change impacts. So we have to, we got all the data, tools, analysis tools and information, what is going to happen. So these are projections only, but we need to develop demand assessment methodology. What is going to change? I mean, if temperature is rising or precipitation is changing, how that is going to impact our demands. So I just conducted a study in Sarda Sahak Command area, where the and it should be done on a spatial scale. I mean, it's not a lump sum estimation. It should be where that impact is going to happen. So, for example, this is a command area, so most of the impact will be seen in eastern parts rather than on northern parts. And how much impact, how much demand will increase, those kind of things can be assessed by this methodology that we have developed. So this is the one of the requirement. I mean, one person cannot do everything. So I'm just for the benefit of audience, raising the issues which are contemporary and which are important as far as water sector is concerned. Next one, please. And as I said, because water assessment, I mean, water resources assessment is complex hydrological process. We do it by by developing some simulation model after some measurements. So one of this model is showing that if what is the impact of land use changes on water resources of a particular watershed. If it is developed watershed, then monsoon rainfall will be runoff will be less, and that will be reflected as a benefit because you're conserving water, you're increasing the absorption capacity of the watershed or the landscape by doing some conservation measures. So that will be reflected as a benefit by increasing the flow during lean period, that is January, March, or April, June. On the other hand, and these are based on real observations. So, of course, the modeling studies for providing a robust estimate. If, on the other hand, if the watershed is degraded, then there will be more monsoon runoff and less of water availability in lean period months, that is January, March, or April, June, summer season. Similarly, we can assess what will be the yield of that particular water source if there is a less rainfall by 20%, 40%, 60%. So these kind of estimation are to be done for the potential water sources which are serving to a large mass of stakeholders so that we can manage them properly and make the water availability sustainable in that particular area. So this kind of study is also, information generation is also required. Next one, please. Next one. Yeah, this is same thing, modeling impacts of climate change. Suppose if temperature is changing or projected to change, what is going to impact? So if temperature is changing, our demands, not only crop ET, our own domestic water requirements are going to increase. So that everything has been assessed, and by developing a methodology, and same methodology can be applied to other areas also. And when and where, in which month where there will be water surplus, is in which month there will be water scarcity and how much. So those kind of things can be estimated, and then we can take some ameliorative measures to mitigate the climate change impact. So these are, I'm just showing these kind of tools and studies have been conducted. They are available and they can be used for solving problem of a particular region. Next one, please. So coming to the management part, one technique that is water harvesting, which implies that augmentation of available water resources, that is artificial recharge of groundwater storage or spring or aquifers. And spring is also a type of groundwater storage. Or creating new sources within the area, impoundment of surface water. So as I said, impoundment of surface water has some limitation due to siltation problem. The best policy that was propagated during 11th plan, and now in other development scheme like PMKSY, is to induce groundwater storage. More of the water, rainwater, that 60% component, remember, not the rivers and stream part I am talking about. Now I'm talking about only that 60% component of rainwater that remains on the landscape, either in the form of soil moisture or it is lost as evaporation. If it is utilized as transpiration, then it is utilization. If weeds and all are transpiring that water, then it is a loss. But that 60% is huge amount. I'll show you the statistics in later on. So that water can be harvested. And it is a fact that if you harvest the rainwater at micro scale, you can harvest a lot of water. If you leave it to flow on the landscape, reach it to the river, then utilize it, it is only 40% component. So that 60% has to be utilized for meeting our increasing demands. So that can be effectively done by increasing groundwater storage, and technology is available. So not only that, now I'll be talking about technologies. Next one, please. Not only that, it's not required that you use all the rainwater to store all the rainwater to groundwater storage. We need to use it like green water that saturates our soil and support our crops and orchards and forest. So for those, these conservation technologies are there which harvest rainwater at micro scale and then supply it for the crop growth or orchard growth or fisheries or whatever purpose you want to use it. They are proven technologies and very effective. Of course, some investment is required, initial investment. They can be done at the individual level. So farmers are now coming over and adopting these technologies for the useful purposes, crop growth or orchard growth. But this part will not recharge the groundwater. Okay. But we need to, as I am talking about rainwater management, so we need to have an holistic approach, which is we promote as watershed management technology. I mean, all these small scale technologies are put in a very perspective, well-planned manner on a watershed scale. And wherever the problem is a different, and whatever suitable technology is there, it is utilized to solve that problem. Either it is erosion or water conservation. And then entire watershed is managed in such a manner that it supports all the requirements of the inhabitants of that watershed. I mean, farmers and villagers. Next one, please. I'll just quickly go through. These are all technologies which are for water conservation, and then utilizing it for different cultivation of different crops or orchards. Next one, please. And they are area specific. I mean, eastern part, northern part. And I have to mention that it is not only for water scarcity management. I mean, where rainfall is less, more water is to be conserved. That is a general thing everybody knows. Not only that, where rainfall is more, humid regions, there also conservation technologies are required. Not necessarily moisture conservation, but erosion control. Because if erosion is occurring, the vegetation will not come up. And you cannot utilize the available water for useful purposes. Next one, please. Just to showcase how different parts of country where different rainfall situations are there, what we have standardized all the technologies and they can be implemented for useful purposes. Next one, please. This is for Bundelkhand region. That is a water scarce region. Next one, please. This is for hilly region. You know, the Himalayas are water towers, but the water flow at the in the rivers at valleys, whereas villages are situated on the ridges. So there also water scarcity they face, although it is not that scarce because rainfall is good. But even then, providing water harvesting sustain their crop and increase its productivity. Next one, please. So different systems have been demonstrated to farmers and they are adopting it. Next one, please. This is again the community water harvesting and how an entire village can be benefited by this kind of system. I'm not going into details of this, but just a showcase of all these successful demonstrations in villages. Next one, please. This is spring water harvesting. This is for non-arable lands. You know, our country is signatory to land degradation neutrality, and there is a lot of degraded lands available. About 1/3 area of our total geographical area is degraded lands, where because there are no conservation measures, there is no vegetation cover, the entire runoff, the rainfall that comes goes as runoff unutilized. So here we have developed technologies for non-arable lands and their economic utilization with conservation measures. So different examples are there for different rainfall conditions. Next one, please. Orchard development, then this is landslide control. Remember, when we are talking about water conservation, we are also talking about erosion control, because both are interrelated, and sediment load in our flowing water in rivers and stream is a big problem. So that can only be controlled at the catchment level. Next one, please. So this is a new intervention where instead of using electrical or diesel energy, in irrigation, pumping is required. The solar powered micro irrigation. Micro irrigation again increases water use efficiency. In less water, you can irrigate more area. So this kind of things are also propagated, and though the initial investment is there, but subsidy is provided by government and farmers are adopting. And it's a very useful setup: water harvesting, solar pump, and micro irrigation. So this is the kind of new paradigm now for utilizing in rainwater management. Next one, please. This is again an example how the farmers are lifting water from the lower region to about 50 meter or 100 meter high by a solar pump and utilizing micro irrigation and taking different crops, now irrigated. So previously they used to be rain fed, but now irrigated, and the adoption rate is very good. I mean, they maintain their system very well, though the technology of solar pump and all requires some kind of maintenance, but it is working. So bringing the technology to door of farmers, I mean, that kind of movement is there now in PMKSY. In a very planned manner, these things are and have been taken up by the government, different governments, state government and central government is also promoting these efforts on a larger scale. Next one, please. So coming to groundwater recharge, because we large number of population resides in rural areas, so we have to start from there. Although urban areas, water requirements are very high because population pressure is there. And one day you do not get water for 1 hour, start making hue and cry and comes in media. That is not the real problem. Real problem is where our majority of population lives and meeting their requirements. So it's rural area, and that is the hot spot for water harvesting. If those areas are made, because anthropogenic disturbances and climate change disturbances are changing these natural water balances. Even the natural rate of groundwater recharge is very less. It is 8 to 9% on the average. In our rock region, it is much less, and it is very difficult. For groundwater recharge, one thing is very important. I think Dr. Gopal Krishnan also mentioned that if you do not attempt to this artificial groundwater recharge in a recharge zone, which can be identified by different technologies, different methods, then there is no benefit. So that location of the groundwater recharge project is important, so that water is induced. We are enforcing water to go deeper into the groundwater aquifer. So this is one of the example in arid zone, where the nature provides us such locations where water is harvested in a natural depression, and there is a permeable layer about 30 to 100 feet below the ground, and one can store that. This water will evaporate in 2 to 3 months. 2 months even it cannot stay because the evaporation rate is very high. But that water seeps down to the underground storage. It's a purged type of aquifer, and an open well is dug, and it is filtered water is available throughout the year. So these kind of small scale methods are also there for groundwater storage. Next one, please. These are the examples in highly degraded ravine areas where if you go in non-rainy season, you won't see any water. But rainy season, if we harvest it like this, like this, like this, plenty of water is there, and it directly recharges. That aquifer is also good for recharge. So by constructing these structures, that water is directly stored in groundwater, and increase water table by 2 to 3 meters, 3.5 meter per year has been observed. So it doesn't mean that it will overflow. It spreads on a lateral scale. This is a point recharge. The water is going down. The water table we observe in open wells or existing wells, or by installing piezometer. It suddenly rises, then it spreads. But that much water is stored in groundwater, and that is available for pumping in a later stage. Next one, please. This is a well-known trenching technology. It can be used for economic utilization of degraded lands where there is no land cover because of no conservation of rainwater, but it conserves rainwater, support the vegetation, and also induce groundwater recharge. Next one, please. Next one. Yeah, not only on landscape, but our water bodies like lakes require a lot of attention in these times because of anthropogenic disturbances created in their catchment. Lake catchments are closed catchments, so all the rainwater falling in the catchment goes to lake and is stored in the hill slopes. Then it is slowly released in the lake so that lake water is always maintained. But because of urbanization, in this particular case, Nainital Lake, we identified a recharge zone for this catchment, installed the conservation measures so that the water flow in the lake remains sustainable during non-rainy season. So these kind of measures are also required because we have disturbed the hydrologic balance of, you must be well aware of the cases of drying up of a spring and drying up of a river, encroachment of those water bodies due to urbanization, but all that can be reverted back by the conservation measures. This is the point I am trying to make, and this has been done at several places. Next one, please. And we have to do it. Otherwise, water demands are increasing, and if we do not manage our water resources, then we'll be in deep problem in future time to come. So this is another example where a degraded landscape like this was converted something like this, and all the due to with the treatment of this watershed. And what we do actually, we enhance the absorption capacity of the landscape so that water is stored on the hill slopes or in aquifers, and then later on available in non-rainy season for different purposes. Even if water is there, there is greenery. there is no water, there is no bean. So you have to, if save our landscape, greenery, our environment, then we have to conserve our water resources and manage rainwater in a very meticulous, planned, data-driven way. So this was a transformation that we brought out in this area in 13 years, and then lean period flow, you can see during the monsoon, of course, there was some flow here, but it was increased to almost, now it is, this is old data, 96. Now it is almost perennial, this source. Next one, please. So these are all very popular in structures in our country. I mean, adoption, when some 20 years ago, nobody was talking about this is the business of government to construct check dams. Now, the village panchayats have taken up this thing in a very demanding manner. I mean, they want to construct check dams for groundwater recharge, for water harvesting, and utilizing it for their own purposes. The benefit of this thing is, besides groundwater recharge, this water is available right in the village. I mean, one can take a pipeline and utilize it for whatever purpose they want. So this is the beauty of small structures. They harvest more water. They are available right where the requirement is there, and the maintenance, etc., is very low. And they are kind of fire and forget type of technology, construct it and then utilize it for different purposes. So in this kind of things, our groundwater recharge increases in the entire landscape, in the entire village. I mean, it's not for 1 or 2 wells, for the entire village. They will enhance the groundwater storage, provided they are constructed at a proper location. So I've seen many cases in Manrega, because of lack of know-how or whatever, they construct it, but no benefits are gained because of inappropriate location. So location is very important, and there are methods to plan where these water harvesting structures should be located in a watershed or a catchment. Next one, please. So we keep on training the people and reaching out to them for these kind of conservation measures. They should take up in their village and get benefit. This is again very well-known trenching. Anywhere it can be done, irrigated land or slopy land, and this increases spring water, groundwater, and establish the vegetation. Next one, please. And minimizes the erosion. Next one, please. Yeah, so this is a nutshell integrated watershed management program. All these conservation measures are taken in a very planned manner for a watershed. The planning is data-driven. Watershed, you know, is a hydrological boundary that contributes where we can assess all the resources. Next one, please. And the purpose is to utilize that 60% invisible water in these watershed programs. So it was a very popular program and taken up by different government agencies and as well as non-government agencies. Even village panchayats, they are following watershed technology for the area development in their respective villages. So again, not only groundwater recharge, but also all kind of benefits are driven by watershed development by the village people. So these are some of the indicators which indicate how the changes occur after the adoption of these conservation measures in their area, and whether they are sustainable or not. These are studies, long-term studies, not long-term, medium-term studies, impact studies. They are done after 7 to 8 years of after the development work has been done in these watersheds. These are the watersheds. Next one, please. So several examples are there, and several agencies have done this kind of thing. Very convincing. Only thing is that capital investment is required, and government is supporting that through their various development programs. Next one, please. So again, if development is taking place, how the changes are occurring, that is our major concern now. I mean, the agency, suppose any agency, they will execute the work, but I have seen that the impact assessment methodologies are not there to even benchmark data are not there to show what kind of changes have taken place. Only photographs are there, but photographs are, you cannot take photograph every year. So we need to develop some methodologies where on regional scale assessment can be done, that what is the impact of all the development work that has been implemented in certain places. The regional analysis. So these are some of the parameters and methodology. About 68 million hectares have been treated under various integrated watershed management program. So first indicator is reduction in erosion. And then we found that yes, erosion rate has reduced to this rate from the what was there 30 years ago. So it's a slow process. So we have to assess it in long term, and some complex analysis is done for that. And this was attributed to all the conservation measures and irrigation, of course, that has been adopted by our Indian agricultural sector. Then what is the water productivity of different measures that has to be done on a small scale, and that also we have shown how it improves or degrades depending upon how the work has been undertaken. So methodologies are available that can be applied. Next one, please. This is pure physics-based criteria for where we can assess the impact of development work done. I'll not go into the technical details, but this we are working on. Next one, please. So we have developed some database to assist in these kind of studies. And a water sector policy is required for need fresh assessment of water resources, and not only visual water, but invisible water also. And we have tried to do that. Next one, please. So this is the last slide, I think, from the involvement in various kind of development activities. What message can be given to the audience which are interested in water sector, that large scale water infrastructure alone is not a panacea. So we get overexcited by the news of construction of dams and barrage, but that is not the real problem solver. Again, we have to consider all the hydrologic consideration upstream, downstream, because if you are developing some water infrastructure in upstream, downstream is affected. So a well-laid planning is required. And that is the main focus of PM-KS5, now the new program of the current government. And they're following a data-driven policy to make a regional plan, then take up the development activities. So sustainable development should take account of hydrological variability and appropriate risk management policies in all climatic zones. This is more relevant in current climate change situation. So this is in a nutshell, I wanted to share with you what is required in water sector for food security. Thank you very much.
Thank you so much, sir. Indeed, I would like to highlight that the presentation was very much focused on the real life applications, not just the theoretical part. It was too much on on-field experimentation, that how we can actually improve the groundwater recharge and increase the number of water bodies. So it was not basically just the bookish or the theoretical derivations. It was basically on-field investigation. So that was definitely a good part, that it was applicatory. Apart from this, just a quick question for this. So do you think that how would you like to integrate rainwater management into these broader sustainable goals, like say relate rainwater harvesting for poverty reduction? So can we relate it together?
They are already. If you
They're all-
develop a water resource for a individual family or even on a community basis, you interact with them. They're so happy to see water. And it changes the entire routine of that particular family or village if water is available. So all these measures are already related to those SDGs. The only problem is technical know-how, the data, the information that is required, the location is decided based and design is based on certain data that is required, and capital investment.
Finance is
So
always a
that is
problem.
not available with the farmers, but government is doing it. I mean, they have authorized panchayats to take up these works with their own funding. So slowly, I mean, I can tell you that in a span of 30 years, when people were not willing to construct a farm pond in their field because a certain area is lost. Now they are lining up. Yeah.
Yeah.
So
Definitely, that's a positive change. So I'll definitely say this is the highlight of your presentation was the applicatory part, that everything was done on field and everything was making a change. It was not just about telling the change or saying about that we can do this, we can do that. We are doing this and this is bringing that. So
that was the
that part was
purpose. I didn't get into technical details much.
I
I mean,
agree
that was
with
the
Dr.
purpose.
Thank you, sir. I agree with Dr. Juhi that your presentation totally towards the research based, and it clearly indicated a lot of things or a lot of project or research which we can do under the underground water resources, means field based study. So thank you so much, sir. Really, your presentation is excellent presentation.
Thank you so much.
Thank you.
Moving forward, I have my third speaker with me, but just want to confirm it again. Mukesh sir, do we have you with us?
Yes, ma'am, I'm here.
Okay, sir. I would like to introduce my next speaker, Mr. Mukesh. Mr. Mukesh Anand, Scientist B in the Central Groundwater Board, Raipur, Ministry of Jal Shakti, Government of India. He has cleared the prestigious UPSC combined geoscientist examination in 2019 and has secured his position in different prestigious exams, including GATE, CSIR, NET, JRF, and he has currently joined CGWB in 2020. His basic interest areas are national aquifer mapping, groundwater resource assessment, climate change, and tectonics. He has done numerous works in the related fields, and we would like to hear from you, sir, regarding the current day topic. We would like to welcome you first with our virtual Tulsi sapling. Dr. S.P. Singh sir is presenting the virtual Tulsi sapling to you, sir.
Thank you so much, ma'am, for introducing me. First of all, I would like to say that I'm not that much big here that has been introduced. I'm just a kid in front of all the dignitaries and started my career just in this sector. And definitely learned a lot from this webinar. With your permission, can I share the screen?
Yes, sir.
Is my screen is visible? My slide?
Yes, sir, it is visible.
So make it full screen mode, sir.
Yeah,
Sir,
yeah,
put it in. Yeah.
yeah. It's groundwater conservation. It's visible.
Yes, sir. Now it's visible, sir.
Okay, thank you. From the last 1 hour, we are talking on this groundwater and water conservation. Why? Means, as we know that the groundwater and the water resources are natural resource, and these are very limited to us. We are the only stakeholders along with all the natural beings, and we need to conserve it for the sustainable use to so that it can sustain it to next future generations. रिसोर्स बहुत ही लिमिटेड है और अगर हम कंजर्व नहीं करेंगे तो आगे जैसे कि हम देख पा रहे हैं हमें मतलब विदाउट एनी स्टैट्स इफ आई एम टॉकिंग कोई भी ग्राफ या स्टैट्स के बिना भी अगर हम अपने रियल लाइफ में देखें तो बहुत ज्यादा शॉर्टेज है हर जगह बैंगलोर और बहुत से मेट्रो सिटीज है जो कि पहले ही ग्राउंड वाटर के उसमें मतलब जीरो वाटर के स्टेज में जा चुकी है बट a lot we can do now if we awake early, we can do now. So moving next, why means why this topic has been in in heat. Last in March 2023, this year only, United Nations have conducted World Water Conference. In that, the UN Secretary has said a very ravishing line that vampiring overconsumption and overdevelopment, unsustainable water use, pollution, and unchecked global warming are draining humanity's life. Water is not only water is a blood for life. Means every drop counts, and we are using it in a very over consuming it. We are developing the aquifers on a very over exploited state, and इसको कंट्रोल वे में नहीं यूज करेंगे हम तो we will face a huge loss. So infographic, you can say that there is a supply gap of 69.25% liters per day, and there is a list of 30 urban areas which are facing the currently they are facing this water scarcity problem, and up to by 2050, here it is 2050, but we can say that up to 2030 when we will face the problem of water scarcity. We have to take steps, and without waiting we without waiting we have to take some actions. कल करेंगे नहीं, अभी करेंगे तभी ये problem solve होगी. We have to conserve the water through artificial recharging, rainwater harvesting, and all. This PPT will consist of mainly the government schemes, the interventions made by government for the conservation of water, and that too are followed by our local peoples. Okay, we can see this graphic. 54% of India faces extremely high water stress. 16% of country is in drought, and 50% people are exposed to drought. 68% of sowing area is subject to drought. Means you can see these stats. We are in a huge problem regarding the water resources, and definitely I also appreciate that many of the warriors of the water warriors are working tough for the conserving the water, and they are renovating these water bodies and all, and many researchers are also developing the aquifers and also their interventions. Okay, some alarming figures are there. In March, UNESCO relates its World Water Development. In that we can see that urban areas are facing a huge water scarcity problem. 80% of people living under water stress currently, they are in only Asia, particularly in Northeast China, India and Pakistan. ये ऐसा इसलिए है कि इधर के जो एक्विफर्स है वो हाईली पोटेंशियल है. हमारा जो ऊपर का एरिया है, नॉर्दर्न एरिया, वो इंडो गैंजेटिक प्लेन में आता है. हिमालयस के नीचे जो इंडो गैंजेटिक प्लेन है वो काफी ज्यादा पोटेंशियल है, और वो बहुत ज्यादा यूज हो रहा है पंजाब हरियाणा में। उधर हमने जो भी वेल्स ड्रिल किए और जो भी एक्सप्लोरेशन हुआ वहाँ पे डिस्चार्ज बहुत ज्यादा है, 20 LPS 30 LPS मीन्स कि उसका डिस्चार्ज तो हम लोग वो जो इंस्ट्रूमेंट होते हैं हमारे उससे तो ले ही नहीं पाते, वो चार्ट के थ्रू ही हम लोग निकालते हैं, इतना ज्यादा डिस्चार्ज है। बट और उतनी ही ज्यादा उसे यूज किया जा रहा है। दीज आर दी एक हमारा नॉर्थ है, एक हमारा साउथ है। साउथ में कई जगह है एक्विफर्स को बहुत अच्छा प्रिजर्व करके रखा है उन्होंने, उसको वो हेरिटेज स्ट्रक्चर समझते हैं। और हमारे नॉर्थ में सरफेस वाटर बॉडीज होने के बाद भी उसमें एम्पल अमाउंट ऑफ वाटर है, उसको अगर वाइजली यूज करें तो हम लोग को इतनी ग्राउंड वाटर की इश्यूज नहीं होगी। दैट देन आल्सो वी आर मींस एक्सप्लॉइटिंग द ग्राउंड वाटर। इफ वी यूज वाइजली देन वी कैन सॉल्व। And we all know that in terms of climate, India is a tropical country which experiences extreme hot summers. इंडिया में जो भी इवेंट्स क्लाइमेटिक इवेंट्स होते हैं वो एक्सट्रीम होते हैं, चाहे वो एक्सट्रीम हॉट समर्स हो चाहे वो विंटर हो। देयरफॉर अगर समर बहुत ज्यादा हॉट है तो हमें वाटर की जरूरत पड़ेगी ही पड़ेगी और पड़ती ही है। और 18% we are the 18% of world population and only 4% of water resources we have. That's very means horrible figure. And we can see the stats of 2001 that per capita water availability, it was 1,816 cubic meters, which reduced to 1,486 by 2021, and its expected decline is 1,367 by 2030. So therefore we need to take care of it. One major factor is heated issue that is coming out, that is climate change, which exacerbates this problem. How I can tell that rainfall events are becoming very extreme, means the intensity of rainy days has been changed. We have 10 to 15 days of heavy rainfall. Earlier it was 2 to 3 months of moderate rainfall, which sufficiently recharges the aquifer. ये रेनफॉल इंटेंसिटी चेंज होने से प्रॉब्लम बहुत सारी होती है कि सॉइल वाटर जोन में बहुत सारे इंटरवेंशन होते हैं। वाटर का एक रेजिडेंस टाइम होता है, अगर वो सही टाइम तक वो सॉइल में रहेगा तो बहुत अच्छा वर्क होगा। प्रॉपर केमिस्ट्री जो होगी, वो केमिकल रिएक्शन जो होंगे प्रॉपर टाइम से होंगे। बट अगर ये रेनफॉल इंटेंसिटी का जो टाइम है ये चेंज हो रहा है, ये बहुत ही हॉरिबल। मतलब इससे कभी कभी होता है कि कई कई जगह की सॉइल है वो चोक हो जाती है, उस पर कैल्सिफिकेशन हो जाएगा जल्दी और वो प्रॉपर कैल्शियम डिसॉल्व नहीं हो पाता है, जिसके कारण रिचार्जिंग बहुत स्लो हो जाए। ऐसी प्रॉब्लम हम लोग देख सकते हैं हमारे यहाँ छत्तीसगढ़ में, नॉर्दर्न छत्तीसगढ़ में सूरजपुर डिस्ट्रिक्ट है और ये सब जो गोंडवानास में आ जाए, जाके प्योरली जियोलॉजी सैंडस्टोन है और बेसिकली हम लोग जानते हैं कि सैंडस्टोन अच्छा रिचार्ज करता है। देन आल्सो वी आर फेसिंग प्रॉब्लम बिकॉज द लोकल पीपल से दैट सॉइल हैज लॉस्ट इट्स कैपेसिटी टू परकोलेट द वाटर। दिस इज द सेम, and this is only happened due to this climate change, and climate change is directly indicated, directly linked to the anthropogenic. It's written clear here that it makes the monsoon erratic, and it changes the groundwater, soil water chemistry, and many more things happen, that the oceans are becoming weak as a sink. They are not capturing too much carbon dioxide. They are best sink for the carbon sequestration. So they are also weakening. Moving forward, not talking too much about the crisis, we should go for the conservation methods. One of the conservation method is right now invented one water approach. The government is promoting one water. Many organizations are there in India who are working on this water sector. Some are working on groundwater especially, and some are working on surface water, but the water is water, not a surface water, not groundwater. We have to take it as a one entity. So then only we can conserve. So the mindset, we have to develop the water as a value in our ecosystem to our drinking. And wastewater, stormwater is also the component of that water system. Multifaceted approach we have to develop. Means we have to invest in water for the economic, environmental, and societal reasons. And basic thing is we have to conserve. We have to plan this recharging or anything regarding water conservation on a watershed scale, because the basic from ridge to valley we have to conserve. Means the watershed, when we make a recharge plant, we give the structures so that it can means recharges from the ridge to valley, from the ridge to valley. We can recharge the water. Not means we cannot leave any component. And private partnership and inclusions we have to also make. Some NGOs and all. UNICEF is also working in this water conservation work. Their wash and sanitation department is doing excellent work in the water conservation. And in Northeast, spring shade management is also very common. And one Dhara Vikas Yojana is also there. The group of it's a self-help group of mainly comprising of the local ladies, which is working on this conservation of the springs. Northeast में springs ही है उनका main source water. तो अगर उसको वो लोग conserve कर रहे हैं through sacred means they are making some temples and on some puja stalls near to the spring discharge points, so that no one can pollute it. हमने देखा कि हमारे नॉर्थ में रिवर्स बहुत पॉल्यूटेड है. यमुना इज वन बेस्ट एग्जांपल वी कैन सी, एंड गंगा इज आल्सो मींस in early times it was polluted, but now the prestigious Namami Gange mission came, which is working excellent in this sector. तो प्रैक्टिसशिप्स वगैरह करके हम लोग अपने स्टेक होल्डर्स को अवेयर कर सकते हैं, ताकि वो, क्योंकि यूज हम ही लोग कर रहे हैं और हम ही को उठना पड़ेगा कि अगर हम वाटर को प्रॉपर्ली कंजर्व कर सकें. So these are the means what it's the objective of One Water: reliable, secure, and clean water supply, which is means going through Jal Jeevan Mission, aquifer recharge. We are doing through national aquifer mapping. We are doing this aquifer recharge. Means we are preparing a aquifer recharge plan and submitting it to all the districts, to the collectors, to implement it for recharging their aquifer. Flood protection. And flood protection mainly is CWC is doing this these works to dam safety and all. Minimizing environmental pollution. I can say that the Central Pollution Control Board is doing excellent work in minimizing the. They are means providing governing these water laws and all, so that this should be checked time to time. Efficient use and reuse of natural resources. Resiliency of climate. Many research organizations are working on this climate change, so that some excellent research could come out. So to fight this water scarcity issue. Long-term sustainability. This year, Jal Shakti Abhiyan is the main theme of Jal Shakti Abhiyan this year is the sustainability of drinking water. They are the mission focuses on this to sustain the drinking water sources, whether it was Jal Jeevan Mission sources, whether it was surface water or the groundwater supply agencies. Equity, affordability, accessibility to safe drinking water, economic growth, and prosperity. These are the major objectives of the One Water approach. In the figure, we can see that how it is connected. And once we will consider all the components of the water as a one entity, then only we can attain this goal of water conservation. Here we can see that we have to conserve nature, drinking water, surface water, groundwater, storm water, recycled water also, and wastewater. Next is integrated water resource management. It's a part of the One Water approach. In this integrated water, the water is reused and recycled several times. It's the best example we can see in this integrated water resource management. It's done by Eli Steel Plant. They are doing a very excellent work. They are last year in 2021, they got the prestigious national water awards for. They are maintaining the zero discharge, means they are not discharging any wastewater into the nearby tanks or surface water bodies. They are using and recycling that water only in their plant. The storm water is utilized as a valuable resource to fight water against stress. The storm water is also used, and right now government is promoting the district collectors and all to make some plans to reuse this storm water. Water system includes clean infrastructure, and we can develop a green belt using this grey water. In Jal Shakti Abhiyan this year, I visited North Goa district. They have maintained a separate filter plant of they are treating the sewage water of the area, and after using that treated water, they are developing a green belt in all that area, because they have divided the sectors, and they are developing the green belt using that sewage water. So excellent means they are using this sewage water. They are not wasting it, not means discharging it into any surface body or polluting. They are using it for the developing the green belt. Surface water, groundwater interconnections would also be there. Active collaborations with industry agencies, policymakers, leaders. It is needed. It is too much needed to conserve the water. Active collaborations are needed with the industry. We have promoted also many industries in our public interaction program to learn from this steel plant and other industries who are using the water efficient technologies in their plants, because they are properly conserving and they have proper stats and data that per day how they are conserving, how much they are conserving. And the best example of integrated water resource management, the role model in this sector is the country is Israel. It's very astonishing to see that they are capturing the atmospheric moisture through large filters and using it in their daily use. They are fully dependent on the saline water. They are treating it and making up to drinking water, and they are means we can't say that if we have no fresh water we can't live. Technology is rising, but if we have the fresh water, we should conserve. At least we ऐसा स्टेज नहीं आने देना है कि जहां हमें फिर saline water को use करना. Okay, I am listing some interventions made by government. Central Pollution Control Board ने नेशनल क्वालिटी मॉनिटरिंग प्रोग्राम बनाया था. जहां तक एक रिसोर्स है, अगर उसकी बात करें तो क्वांटिटी के साथ साथ उसकी क्वालिटी भी बहुत इंपॉर्टेंट है. बहुत सी ऐसी जगह है, हम अभी छत्तीसगढ़ में वर्क कर रहे हैं, यहाँ पे वो पानी बिल्कुल ही पीने लायक नहीं है in terms of quality. Like Rajnandgaon, it's a hotspot for arsenic. In Sukma, some places are there. They are also arsenic hotspot. In Supebeda of Gariyaband district, they are highly contaminated water due to fluoride. This quality की भी monitoring बहुत जरूरी है ताकि उस water को properly use करें. Otherwise, that resource will become poisonous, and that is in many states of the country. Next, Namami Ganga mission. It's a very excellent program, and we can see the results. So without any stats, if we all roam to the river banks for our in our daily life, we can see that how the clean is river become. And apart from this, for all other rivers, ministry has launched a national river conservation plan. Legislative provisions also Water Prevention and Control of Pollution Act. 1974, they have launched Environment Protection Act. Under this only, our Central Groundwater Authority has been established to regulate the groundwater usage. There is a basic example that अगर हम किसी रेस्टोरेंट में जाते हैं, हम पानी लेते हैं, वो जग में देता है पानी, तो हम उसको कितना पिए कितना छोड़े वो हमारे पास कुछ हो नहीं. अगर हम उससे बोतल मंगाते हैं तो अगर उस बोतल में थोड़ा सा भी पानी रहता है तो हम उसको जरूर लेकर आते हैं, फेंकते नहीं है. तो दैट इज द मैसेज दैट ग्राउंड वाटर को रेगुलेट कर रहे हैं सेंट्रल ग्राउंड वाटर अथॉरिटी. उसके चार्जेस ले रहे हैं हमारे इंडस्ट्रीज से, कमर्शियल यूज जिनका भी हो रहा है उनसे चार्जेस ले रहे हैं ताकि वो वाइजली यूज करें और उसको रेगुलेट करें. और उसमें हमने ये भी रेगुलेट किया है कि वो प्रॉपर रिचार्ज करें. रिचार्ज का भी एक डेटा दें हमें कि उन्होंने कितना क्वांटिटी को रिचार्ज किया है, कितना पानी को ग्रीन बेल्ट में डेवलप किया है, ग्रीन बेल्ट डेवलप करने के लिए यूज किया है, और कितना वो ये माइंस में माइन पिट से कितना ले रहे हैं. मतलब एक प्रॉपर डेटा बैंक है जो कि डेवलप किया जा रहा है सेंट्रल ग्राउंड वाटर अथॉरिटी द्वारा, और ग्राउंड वाटर को प्रॉपरली रेगुलेट भी करना है. और साथ ही साथ इससे जो रेवेन्यू जनरेट हो रहा है वो कंट्री के काफी मतलब रिचार्ज प्लान्स और अदर मिशंस में इसको यूज किया जा रहा है. नेशनल वाटर पॉलिसी के एक अच्छा डॉक्यूमेंट है. जो भी स्टूडेंट जुड़े हैं कहेंगे इसको नेट पे टाइप करके पढ़े. बहुत ही अच्छा पॉलिसी है. इसमें 10-12 पॉइंट सेलिएंट फीचर्स हैं इनके, बहुत अच्छे लिस्टेड किए गए हैं। ओके, जल शक्ति अभियान was launched in 2019. Main key focuses on water conservation and rainwater harvesting. It's a tagline: catch the rain where it falls when it falls. You can see that in our state, Chhattisgarh state, you can see the 1200 mm rainfall. It's very high. I belong to UP. वहाँ पे इतनी बारिश नहीं हो रही है अभी, क्लाइमेट चेंज के चलते बहुत जगह बारिश बहुत कम हो रही है, बट यहाँ पे टाइमली मॉनसून टच कर रहा है और बारिश अच्छी हो रही है। थोड़ा बहुत डिफिशिट हुआ है, बट अभी भी हमारे पास एम्पल अमाउंट ऑफ रेनफॉल होता है। अगर इसको प्रॉपरली कंजर्व करेंगे तो ये जो गर्मियों में जो टगवेल और बोरवेल सूखने के इश्यूज आते हैं वो नहीं आएंगे। और रेनोवेशन ऑफ ट्रेडिशनल एंड अदर वाटर बॉडीज, नॉर्थ गोवा डिस्ट्रिक्ट ने बेस्ट एग्जांपल सेट किया है। उन्होंने सारे टेंपल पॉन्ड्स, इवन दो मॉस्क्स में भी जो पॉन्ड है उनको अच्छा डेवलप किया है, और सबसे बड़ी चीज उसमें कोई भी रिचुअल्स वो नहीं करने देते, उसको प्रॉपरली प्रिजर्व किया है। वो साल में सिर्फ एक बार खोलते हैं किसी पूजा के लिए, उसको डेली पॉल्यूट करने का या कोई भी रिचुअल्स करके मतलब उसमें गंदगी करने का कोई भी परमिशन नहीं है। उसको प्रॉपर प्रिजर्व करके रखा है, पुराने स्ट्रक्चर्स हैं वो। reuse of water and recharging of structures, watershed development. Earlier also I defined the importance of this watershed development. Intensive afforestation, forest में हमने भी कोरबा और ये नॉर्थ गोवा के फॉरेस्ट हमने विजिट किए थे जल शक्ति में। तो इंटेंसिव एफॉरेस्टेशन कर रहे हैं वो लोग, अलग अलग तरह के डीएम के अंडर एक हॉर्टिकल्चर डिपार्टमेंट अलग से होता है जो कि इन अलग अलग वैरायटीज के प्लांट्स को लगवाना और उनको प्रॉपरली प्रिजर्व करना, उनको कल्टीवेट करना, ये जिम्मेदारी रहती है। तो ये भी एक अच्छा स्टेप है बहुत, क्योंकि हम बेसिकली जानते हैं कि जब सॉइल में वो रूट्स को जब कैप्चर करेगा पानी, तभी क्या कहते हैं प्रॉपर रिचार्जिंग हो पाएगी। पेड़ ही नहीं रहेंगे तो रिचार्जिंग, फिर वो रन ऑफ में इतना पानी वेस्ट होता है बिना पेड़ न होने के कारण, वो प्रॉब्लम बहुत ज्यादा बढ़ जाएगी। कितनी भी बारिश हो, रन ऑफ इतना ज्यादा होगा, हम प्रिजर्व नहीं करते। ड्रिंकिंग वाटर सैनिटेशन, उसकी भी प्रॉपर फैसिलिटी को मेंटेन किया जाए डिस्ट्रिक्ट कलेक्टर्स द्वारा, ये इस मिशन में था। अटल भूजल योजना, इट्स अ वेरी प्रेस्टिजियस मिशन, 6,000 करोड़ स्कीम अंडर वर्ल्ड बैंक। ये पहला और सबसे बड़ा कम्युनिटी पार्टिसिपेशन बेस्ड वाटर कंजर्वेशन मिशन। इसमें बेसिकली वुमेन्स को आगे लाया गया, क्योंकि इसका बेसिक थीम ये था कि घर में हम लोग देखते हैं हमारे मदर हैं जो भी, बेसिकली कई लोग को पता रहता है कि उनके घर में कितने लोग हैं, वो दिन में कितने ग्लास पानी, मतलब इस तरह की डिटेल्स, ऐसा ये डेली एक्सपीरियंस है कि हाँ। और वुमेन्स को इसमें आगे लाया गया। इसकी टैगलाइन थी कि नारी शक्ति से ही जल शक्ति, और ये बहुत सक्सेसफुल मिशन रहा, अभी भी वर्क कर रहा है। गुजरात, हरियाणा, कर्नाटका, मध्य प्रदेश, महाराष्ट्र, राजस्थान एंड उत्तर प्रदेश, ये वाटर स्ट्रेस्ड डिस्ट्रिक्ट्स की संख्या इन राज्यों में बहुत ज्यादा थी, इसलिए इन राज्यों को लिस्ट किया गया अटल भूजल योजना। और अभी जहाँ तक न्यूज है, ये एक्सटेंड भी किया जाएगा और भी स्टेट्स में ऑन द बेसिस ऑफ द वाटर स्कैर्सिटी डेटा। इसमें साथ ही साथ कम्युनिटी पार्टिसिपेशन के साथ आर्टिफिशियल रिचार्ज प्लान भी बनाएगा। वाटर सिक्योरिटी प्लान CGWB ने दिए हर एक डिस्ट्रिक्ट के लिए, मैक्रो लेवल प्लान दिए, और ट्रेनिंग्स कंडक्ट कराई लोगों को, क्योंकि मास अवेयरनेस ट्रेनिंग होती है वो कंडक्ट कराई। नेशनल वाटर अवार्ड्स भी इसी टाइम से कंस्टिट्यूट किया गया कि ये जो गुड प्रैक्टिसेस हैं उनके लिए इनको इंसेंटिवाइज हो, एनकरेजमेंट मिले। लास्ट ईयर छत्तीसगढ़ से भिलाई स्टील प्लांट को मिला, और छिंदिया ग्राम पंचायत सूरजपुर डिस्ट्रिक्ट का, उन्होंने भी बहुत अच्छा काम किया, वाटर शेड बेसिस पे काम किया। वहाँ के कलेक्टर का ये कहना था, उन्होंने अपने जो भी टेक्निकल ऑफिसर्स थे जो इस मिशन के लिए वर्क कर रहे थे, उन्होंने रालेगांव सिद्धि भेजा ट्रेनिंग, क्योंकि रालेगांव सिद्धि एक बेस्ट एग्जांपल है वाटर कंजर्वेशन के लिए। अगर स्टूडेंट्स को कभी भी मौका मिला तो जरूर विजिट करें। वहाँ का हर एक बंदा हाइड्रोजियोलॉजिस्ट होगा, मतलब इस तरह का एक्सपीरियंस है वहाँ के लोगों का। तो उन्होंने बहुत अच्छा काम किया, हर एक पॉन्ड्स को डीप किया, उनकी गहरीकरण किया और नए पॉन्ड्स बनाए। प्रॉपर वहाँ पे एक चैनल था बहुत, जो पहाड़ी से पानी निकल रहा था, छिंदिया रंपा नाला नाम से था, उसको उन्होंने चैनलाइज किया, कैबियन स्ट्रक्चर और लूज बोल्डर चेक डैम्स बना, उस पानी को प्रॉपर चैनलाइज करके आसपास जहाँ कभी सालों से खेती नहीं हुई थी वहां पे प्रॉपर खेती हुई, और सक्सेस स्टोरीज भी इसकी पड़ी हुई है यूट्यूब पे। मास अवेयरनेस में सिटी डेवलप की बात करें तो हम लोग हर साल पब्लिक इंटरैक्शन प्रोग्राम कराते हैं हर एक एरिया डिस्ट्रिक्ट में, जो कि स्टडी में लिया गया है ताकि वहाँ की प्रॉब्लम्स लोगों से जान सके और उसके सॉल्यूशन जहां तक वो उन्हें दे सके, सॉल्यूशन ऐसे कि जो वो खुद से अप्लाई कर सके विदाउट एनी गवर्नमेंट हेल्प। इसकी गवर्नमेंट हेल्प तो मिलेगी लेकिन जो बेसिकली वो अपने स्टेज पे जो उसको सॉल्व कर सकते हैं। और भी इन 2 साल से सर्विस में जहाँ तक लोकल एक्सपीरियंस से जो नॉलेज मिलती है कि लोकल लोग जो बताते हैं वह जो प्रॉब्लम होगी थ्योरेटिकल उतनी नहीं मिल पाती, थ्योरेटिकल से हमें अप्रोच मिलता है कि हमें किस डायरेक्शन में जाना है। तो ये मास अवेयरनेस प्रोग्राम से बहुत हेल्प मिलती है और लोगों में जागरूकता आती है कि ऐसे भी टॉपिक्स हैं जिन पे बात करनी चाहिए। नहीं तो पानी तो वो यूज कर रहे हैं, उसे बहा रहे हैं प्रॉपरली, कुछ लोग यूज भी कर रहे हैं, कुछ लोग मिसयूज भी कर रहे हैं, बट जब तक इन टॉपिक्स पे बात नहीं होती है, ऐसे गैदरिंग नहीं होती तब तक इसकी इम्पोर्टेंस नहीं पता चलती। और हमारा जो सक्सेसफुल मिशन था पुराना महात्मा गांधी नेशनल रूरल एम्प्लॉयमेंट गारंटी स्कीम इंजीनियरिंग, इसके तहत प्रधानमंत्री कृषि सिंचाई योजना एक वाटरशेड डेवलपमेंट कंपोनेंट था, इसको लॉन्च किया गया और मोर ड्रॉप पर क्रॉप कंपोनेंट को इन्होंने यूज किया 2015-16। वाटर यूज एफिशिएंसी पे इसका ज्यादा फोकस था, इसी के उस समय वाटर यूज एसोसिएशंस बने क्योंकि सरपंच और उनको कंप्राइज करके बनाया गया था कि प्रॉपरली वाटर यूज करने के लिए एग्रीकल्चर में लोगों को ट्रेन करते थे और उन्हें मतलब जो गवर्नमेंट के इंसेंटिव्स हैं और वो सब के बारे में किसानों को बताते थे। अभी भी वो मिशन सक्सेसफुल चल रहा है कई स्टेट्स में। माइक्रो इरिगेशन के लिए लोगों को इनकरेज किया गया और देख सकते हैं ड्रिप इरिगेशन बहुत जगह हमने अपने फील्ड विजिट में देखा यूज हो रहा है ड्रिप इरिगेशन, और स्प्रिंकलर इरिगेशन सिस्टम भी बहुत जो अच्छे पढ़े लिखे जो किसान हैं जो काफी डेवलप्ड हैं अपने एरिया में, वो लोग यूज कर रहे हैं और उसको प्रमोट भी कर रहे हैं ताकि हर स्टेज पे वो जा सके। ड्रिप इरिगेशन और ये स्मार्ट इरिगेशन स्मार्ट टेक्निक है ताकि पानी को एफिशिएंटली यूज कर सके, कम पानी में हम ज्यादा काम कर सके। वाटरशेड मैनेजमेंट बेसिकली मैंने बताया कि हाँ ये वाटरशेड के बेसिक पे ही सारे रिचार्ज प्लान और वो बनाने चाहिए क्योंकि ये बेसिक है कि पानी कहाँ से आ रहा है और कहाँ जा रहा है, ये वाटरशेड ही एक बताता है। हरियाली एक सेंट्रल गवर्नमेंट स्पॉन्सर्ड स्कीम थी वाटरशेड डेवलपमेंट की, जो कि रूरल पीपल को पानी बचाने के लिए ड्रिंकिंग इरिगेशन फिशरीज में प्रमोट कर रही थी और हेल्प कर रही थी। ग्राम पंचायत इसको एग्जीक्यूट कर रहे थे। एक बहुत ही सक्सेसफुल वो रहा नीरू मीरू वाटर एंड यू प्रोग्राम आंध्र प्रदेश में। अरवारी पानी संसद, जल संसद बहुत जगह, ये यहीं की बात नहीं है, यूपी में और एमपी में कई जगह जल संसद क्या कहते हैं बनाए, जल संसद ऑर्गेनाइज कराया जाने लगा डीएम डिस्ट्रिक्ट कलेक्टर्स के द्वारा ताकि लोग ज्यादा से ज्यादा पानी के यूज करने के लिए जागरूक हो सके। अपनी प्रॉब्लम जैसे कि वो हमारे पब्लिक इंटरेक्शन प्रोग्राम में बता रहे हैं, वो अपनी प्रॉब्लम इम्प्लीमेंटिंग एजेंसीज को बता सके ताकि वो पानी को प्रॉपरली यूज कर सके। और यूज करने के लिए हमने पुराने जैसे जोहाज, पुल्स, टैंक्स, ये जो ट्रेडिशनल वाटर कंजर्वेशन मेथड्स है ये भी काफी प्रमोट हुए और बहुत अच्छा एग्जांपल सेट कर रहे हैं ये राजस्थान और बहुत सारे स्टेट्स में ट्रेडिशनल वाटर कंजर्वेशन। Some other interventions apart from the this water implementing agencies, model building bylaws, इन्होंने रेन वाटर हार्वेस्टिंग को कंपलसरी किया कि कोई भी कंपलसरी बिल्डिंग, कोई भी कमर्शियल बिल्डिंग या कोई भी प्रेमिसेस बन रहा है उसमें रेन वाटर हार्वेस्टिंग जरूर इम्प्लीमेंट करें। और ये बहुत जगह स्ट्रिक्टली फॉलो भी हो रहा है। ये बहुत ही अच्छा स्टेप था क्योंकि सिटीज में कंक्रीट से, प्योर कंक्रीट से अगर प्रॉपर रेन वाटर हार्वेस्टिंग नहीं करेंगे तो जैसा कि हम देख सकते थे पहली स्लाइड में लिखा कि अर्बन एरियाज बहुत ही ज्यादा डेंजर में है वाटर स्कैर्सिटी। और पंजाब और कुछ जगह मिशन चला पानी बचाओ पैसा कमाओ, सेव वाटर अर्न मनी स्कीम, ये इंसेंटिवाइज किया जा रहा था फार्मर्स को जो कि एफिशिएंटली पानी को यूज कर रहे हैं। और इसमें करीब करीब 300 फार्मर्स ने एनरोल किया था कैश इंसेंटिव के लिए, और उन्हें मिला भी क्योंकि उन्होंने इलेक्ट्रिसिटी को सेव किया इरिगेशन के लिए, वाटर सेविंग की 6 से 25% विदाउट एनी एडवर्स इफेक्ट ऑन। Okay, I am ending here. It's a very short talk on the water conservation. It's a very big topic. Need to be. Thank you so much.
Thank you so much, sir. I would say the highlight for your presentation was definitely involving the fundamental knowledge of the field. आपने schemes वगैरह भी बताई, but at the same time जब initially start हुआ था, you basically focused on generating the fundamental knowledge, how this is happening, what are the basic statistics. So definitely that was good. Again, a small question. So
Yes,
basically, if I compare urban and rural areas, what is like the share of groundwater depletion? Like the rural areas are depleting it more or the urban areas?
definitely, ma'am, urban areas, because there are hospitals, factories, apartments. They are depleting, and in rural areas, we can see there is the chances of recharge, but in urban areas, there are less chances of.
But the usage is higher on the urban side. I actually had a doubt regarding the agricultural usage just because they'll be using it as well now in the rural areas. Okay, thank you so much, sir.
Thank you.
Moving forward, I would now like to move towards the last speaker for the evening. Dr. Brijesh Kumar Yadav, Professor, Department of Hydrology, Indian Institute of Technology, Roorkee. He has completed his PhD from the Department of Environmental Resources, UNESCO IHE, Institute for Water Education, Delft, Netherlands. And now he's posted at IIT Roorkee right now. His interest areas include subsurface flow and contaminant transport, plant-soil atmosphere interactions, phytoremediation of contaminated soil water, saltwater intrusion, manage aquifer recharge, bioremediation of non-aqueous phase liquid pollutants, multi-phase flow, carbon dioxide sequestration in deep surface, and many others. He has number of records to his accolade. He has published number of research articles. We would like to welcome you, sir, to the dais. Request my team to begin the presentation happening.
Thank you, Dr. Johi, and thank you very much, Dr. Renaduppa, for inviting me for this important topic. I was traveling whole day, and then I'm able to manage to make my few slides, and I was just listening the last speaker for last few minutes, and I think the general things has been covered very nicely. So I'll be talking about the groundwater resources in general, and what are the problems which are faced by the groundwater resources, and then particularly the groundwater depletion. Okay, so just let me share my PPT and can you see the PPT?
Yes, sir.
Very good. And now I'm moving the slides. Are they movable or no? Can you see the movement?
So slides are moving, sir.
Okay, great. Fine. So I'm keeping the title of my slides. The talk is also groundwater. And if you remember that in recently that we have celebrated World Water, and we kept the UNESCO also kept the title of making the invisible to visible. So why this groundwater is, you can say, the invisible? Because we know that if somebody says the groundwater sources, it means whatever the water which is below the surface is called as groundwater. We cannot see it. So entire water sources which are below the surface, we call it subsurface water. And the water in the subsurface can be there in form of the groundwater or in form of the soil moisture. So if you go from the surface to the subsurface, in the shallow region, you will see a soil maybe partially saturated by water and partially by the air. So that is called as unsaturated zone or Vadose zone. And then if you keep going down into the subsurface, then we'll see a water table. We encounter the groundwater table. So whatever the water resources which is below the groundwater table is known as the groundwater, and the water which is below the surface, including the water which is there in the Meadows zone, is known as subsurface water. Now, if you look at the general figure of the planet Earth, that our entire Earth surface is having around 500 million kilometers square is the area of our globe. Now, out of this, 29% of this surface of the globe is covered by the land mass, and the remaining 70 or 71% even is covered by the water. So that is what we call world ocean water. And if you look at the northern and the southern hemisphere, and this ratio becomes even more dominant in southern hemisphere, where the 81% of the globe is covered by the water. So we see that water is there, but let us see that how this water is limited. Now, if you look at in this slide, this is the bar diagram here. So the 100% if you take the water of the planet Earth, out of this total water, 97% is there either in the sea or maybe in groundwater, which is impacted by salt. So saline water, which is having 97%, and remaining 3% of the global water is fresh water. If somebody says the saline water and the fresh water, you can see the categorization here. So if the salt content is less than 500 ppm, so when somebody goes in your home and then fix the RO system, we ask them to put the TDS level of 100 or 120. So if the TDS level is, let us say, less than 500, we call that water as a fresh water. If it is between 500 to 30,000 ppm, that comes under the brackish water. And if the salinity content is between 30 to 50,000 ppm, parts per million or milligram per liter, then we categorize this as a saline water. There are some chances there may be surface water or the groundwater, which is even having the more salinity what we observed in the sea. There may be salinity more than 70 or 75,000 ppm, especially in the groundwater. In the surface water, we'll talk about some water bodies like Dead Sea and all. So why do we call them a Dead Sea? Because the salinity is so high. So there is no aquatic, most of the aquatic species are not surviving there. And density of this Dead Sea water is very high. If you are you can say want to go for learning, you can use this Dead Sea for your good choice for the sport. So anyway, so out of this 3% of the fresh water, if you look at this distribution of the 3% of the planet Earth, now 68.7% or around 70% of this fresh water is frozen in form of the ice caps and the glaciers. It means on the globe we are having 100% water. Out of this 100, 3% is the fresh water, and out of this fresh water 3%, about 70% is permanently frozen in terms of the in form of the ice caps and the glaciers. So we cannot directly utilize that fresh water. Now, what is the component of the groundwater in the remaining available fresh water which is directly accessible to us? 30.1% of the global accessible water is there in terms of the fresh water. And what are the large rivers, lakes, reservoirs, other water bodies which we look at the surface, they are comprising even less than 1%, 0.9%. It means the second bar here shows that groundwater is having a huge potential in terms of the freshwater availability. But the problem is that the groundwater is depleted at some location. There's a water low conditions at other places. There is some sites which are polluted. There are some sites where we cannot even extract the groundwater. So the motive of showing you this general picture is here, that it is not only the surface water, but it is the groundwater which is having a huge potential to meet our future freshwater demand if we can manage it sustainably. Now, the further this freshwater is categorized here in terms of the lakes and ice caps, so I will skip that last of that. Now, this slide is having all the distributions of the water sources or planet in figures here. So you don't need to look at the entire table. You just look at the figures which are in the red fort here. So you can see in the groundwater. So groundwater doesn't mean that the entire groundwater is fresh water. About 55%, a little bit more than the 50% of the groundwater is also saline in nature. And remaining 45% of the groundwater resources is of having the salinity, which can be directly utilized by us. Okay. So groundwater doesn't mean it is always a fresh water. Now, if you look at a big picture of the entire water sources over this planet, you can see the largest cube here that shows the world ocean. Water in the world ocean. Indeed, directly we cannot use the seawater. There are some techniques where we can convert this saline water into the fresh water, but the energy consumption is so high that we cannot potentially convert the entire seawater into the fresh water. Now, the second largest cube here is there in form of the glaciers and the permafrost. It means that is also permanently frozen water, and that is also not a dynamic water source. And we cannot, industrial use or for the domestic point of view, we cannot rely on that component of the water sources. Now, third cube is showing the groundwater that is in the permafrost, especially in the Siberian region or the high altitude region. You might have heard the soil water is completely frozen, especially the Wedo zone, unsaturated zone. So that is also not accessible. Number 4 is the lakes, and the number 5 is the water in the atmosphere. So very tiny water, though it is a very important component of the hydrologic cycle, especially the water in the atmosphere. Now, the another pie diagram which shows here, the first on the left hand side figure, you can see this is the total water sources, and 99.7. This figure may be different in different literature, but in nutshell, I can say little bit more than 99% of the water either it is contaminated. When I say contaminated, doesn't mean by pollution only. So most of that water is having the high salinity. Some water is polluted, and maybe the other water which is permanently frozen, or we cannot, or maybe very deep groundwater sources which we cannot directly take it out. We cannot extract it. Remaining 3% of the water that is there on the planet Earth is directly usable by the human beings. So out of the total water, only 0.3% is directly usable. Directly usable means it is a fresh water and also accessible to the human beings. Now, further categorization of this 0.3%, if you look at this, groundwater component is very significant here. So groundwater is having the huge potential again for meeting our freshwater demand over this planet. And then you can see the freshwater in the lakes and the rivers which are mentioned over here. Now, question comes that what are the different segments where we use this freshwater, especially coming from the groundwater sources or the surface water sources. In world, most of these freshwater, on average, I say, goes in the agriculture sector. So there are 3 sectors where we consume the groundwater or the surface water. First one is the agriculture sector, industrial sector, and domestic use. So these are the major 3 sectors where we utilize the water. So agriculture accounts the topmost consumer of the fresh water, and primarily it is coming from the groundwater. Then followed by that, it is 22% industrial use and 8% is accounting for the domestic purpose. Now, if you look at the low to middle income countries, this figure, even use of the water in the agriculture becomes even more prominent. That is more than 82%. Okay, and the 10% industrial utilization is going to be less as compared to the high income countries, and then 8% is there in the industrial water. If you look at the developed nations or the high income countries, industrial water use is dominating to the agricultural water use here. That is around 60%, 30% in the agriculture and 11% in domestic. So you must be wondering that why we need so much water in the agriculture sector. Just for example, if I give a simple example of the grain, let's say if you want to grow a wheat or the rice grains of 1 kilogram, more than 4,000 to 5,000 fresh water, liter of the water is needed for producing that grain. If you are taking a cup of coffee, so the amount of the coffee which you are putting in your cup, that also consumes around 3,500 liters of the fresh water. So this is the amount of the water, which fresh water, which is utilized in agriculture sector. If you look at our country, mostly we are dependent on the groundwater, if not always throughout the year, but during the non-monsoon period, during the non-rainy period, we are always dependent mostly on the groundwater sources for agricultural point of view. So we need to improve the agriculture use efficiency, and at the same time, we have to develop the species, or the, you can say, by using the genetic modification of the crops, very efficient crops, which can use less water by without compromising the production of the grains. Now, if you look at this hydrologic cycle here, everybody must be aware about the cycle that, okay, the water goes from the land mass, from the sea into the atmosphere because of the process of evaporation and the transpiration. So due to this evaporation and the transpiration process, the water from the land surface, or the seawater, it goes into the atmosphere, and the air, which is going to contain this load of moisture, is going to move because of the general wind circulation or the global wind circulation towards the terrestrial side. And after getting the suitable conditions, this moisture laden air, which what we call clouds, is going to precipitate, or the water which comes from the atmosphere to the land surface. So what are the amount which is coming from the atmosphere to the land surface is going to be either going back to the atmosphere, or it is going to be running over the surface. That is what we can visually see from our net height, that, okay, it is some surface water is going to be there in the streams, or the sheet flow, or the rivers. And then a fraction of the water which is precipitating over the surface is going to recharge in terms of this infiltration. Infiltration is the process where the surface water is going into the subsurface. Now, most of the engineers, hydraulic engineers, in hydraulics, engineering hydrology, they consider this infiltration, which is going into the subsurface, as a lossage, abstractions. Evapotranspiration and infiltrations are considered as the major lossage of this rainfall, of the precipitation. However, for groundwater hydrologists, for the groundwater sources point of view, this is really not the abstraction. This is the only input which is going to rejuvenate the groundwater resources, because this is the only input which is going to elevate the groundwater table, which has gone down during your non-monsoon period. The groundwater which has been depleted because of the excessive extraction of the groundwater. So the recharging, natural recharging of the groundwater resources by this infiltration process becomes very crucial. Now, what is happening now? Why the groundwater table is depleting now? The reason is that in a limited area where we have changed the land use pattern, okay, most of the surface has been made concretized. If you look at our country, if you go to the urban areas or where the households are there, most of the people, they like to put concrete on their household, in their garage, right? Why they are putting that one? So whatever the water which is going to be fall over the surface is going to be passed away, and we are facing this, isthmus floods, or whatever the urban floods. You might have heard the news now during the raining that lot of floods events are happening. Why it is happening? Because we are not allowing this infiltration process which was naturally happening earlier. So the time of opportunity which has been given for this infiltration to rejuvenate the groundwater resources has been reduced significantly. Why it has been reduced significantly? Because of the change in the land use pattern. The second is the indeed climate change. So changing climatic conditions are also playing an important role by keeping this extreme event where the rainfall is falling in a very limited period but high intensity. That is also not providing plenty of the time for the precipitating water to infiltrate into the subsurface. And that's the reason that even there's a lot of rain at the surface and a lot of runoff water is there at the surface, which is ultimately draining to the sea, but it is not rejuvenating our groundwater resources. It is not recharging our underlying aquifers which are there at the area. So we have to think, we have to change our mindset of changing the land use pattern. I have did most of my PhD as well as my postdoc in Netherlands, and that country is in every state. If you go there, they are not having any concrete structure. the porous bricks are there. So that is going to allow the water resources, and that is not only rejuvenating the groundwater, but also checking the seawater intrusion, because most of the country of this part of this Europe is under the sea. 2/3 of the Netherlands is below the mean sea level. So they are managing their groundwater resources by keeping the natural which are intact without impacted by the human development or any project activities which are taking at the surface. Now, people understand that, okay, how to manage this groundwater. So people have given the name groundwater hydrology. Okay, let us understand what is groundwater hydrology, what is subsurface hydrology, what is subsurface water, what is hydrogeology, what is geohydrology. There are a lot of nomenclature in the literature, and that is going to be great confusion for the people who are very much interested in managing the groundwater sources. We understand that hydrology is science of the water, how this water is appearing over the planet, how it is circulating, how it is distributed over different forms in the atmosphere or at the surface or below the surface. Now, if you are saying about the groundwater, so I'm telling the whatever the water which is below the surface, we call groundwater, or you can say subsurface water. So groundwater hydrology, hydrogeology, some people call it hydrogeology. Maybe if you are hydrologist and trying to understand the geology of the subsurface, because we know the groundwater is there below the surface, so we have to understand the geology of the subsurface, and that is why they call it hydrogeology. Another term is the geohydrology. If I am geologist and trying to understand the hydrology, the term is going to be geohydrology. So it is just like that, father is known by son or son is known by father. But the concept is that in groundwater or in hydrogeology or geohydrology, we understand the interaction of the water, groundwater, subsurface water with the geological formation and whatever the subsurface formation is there. So how this water is stored? There's no patal law. Okay, I understand when I was small, my grandma used to tell me, okay, there's a patal law. If you go more and more deeper, you will see more and more groundwater. But this is not the case. Groundwater is also limited in the top surface of the planet. Okay, doesn't mean that if you keep going down, you will see the more groundwater. So most of the groundwater there in the unconfined and confined aquifer, which are there at the shallow depths of the subsurface. Okay. Now, if I'll summarize that why this groundwater is important for us, so groundwater is indeed a very precious and widely distributed resources over the planet Earth. Why I'm saying this is widely distributed over the planet Earth? You might have used, most of you are sitting in the, let's say in the Amity University. You might be not having any river or any lake, any water body in your campus or near your campus, but you drill a well and you will find some water. So the location of the surface water resources are very, very specific, very limited. But groundwater is widely distributed. Maybe the quantity can vary. Groundwater, you can, maybe in Roorkee, you will see a lot of groundwater, but somewhere else, if the groundwater is limited, especially in the hard rocks, the groundwater is going to be not so significant. But it is much wider, distributed as compared to the, and why it is precious? Because groundwater is the more reliable water resources, either during the floods or during the droughts. It is the groundwater resources which we can rely. During the droughts, indeed, all the water bodies, the water or rivers, they becomes dry, and we can extract the groundwater during the time of our emergency. Similarly, during the floods, when the entire surface water becomes contaminated because of the high water rise or mixing of the sewerage or the septic tanks water and all, so we cannot rely on the freshwater bodies or the surface water bodies. In that case also, groundwater becomes more important. So during the extreme events, it is the groundwater. That is why I'm calling it is a precious and widely distributed resources. Unlike the other mineral resources, the beauty is that groundwater gets its annual recharge from the precipitation. It's not like coal or the natural gas you extract and it will disappear. No, if you are managing your groundwater resources nicely, it can also get replenished. It can also get recharged from the natural phenomena of, you can say, infiltration, or maybe manage aquifer recharge or other structures which we made for aggressively targeting the underlying groundwater aquifers. Okay. So groundwater is the largest source of the fresh water on the planet Earth, excluding the ice caps and the glaciers that I have shown you. And more than 20% of all the water used in the world is obtained from the groundwater sources. I shown you that 30% of the fresh water there in the groundwater, remaining 1% in the fresh water. But what the utilization of the groundwater? Around 20%, maybe now it is 25%, but still there's a lot of potential for developing the groundwater resources. So groundwater provides almost half of all the drinking water worldwide, and about 40% of the water used in the irrigation, and about 1/3 of the supply required for industry is supplied now in India in groundwater. Not only does groundwater sustain the ecosystem, why it is sustaining the ecosystem? You might have seen the perennial rivers. Rainfall is not there. So if you stop the rain, and if there is no contribution of the groundwater in terms of the base flow in the rivers, all the rivers of the world are going to empty into the sea within 17.4 days. So that's the time of residence of the water in the rivers, in the surface water. Okay. So base flow or the groundwater, which is keep contributing during the lean period. When I say lean period, during the non-rainy period, is going to sustain the ecosystem of our terrestrial system. With the rise in the water scarcity and decrease in the availability of the surface water, there's increased reliance and the pressure on the ground. Indeed, we understand now the pressure on the groundwater is high, and that is what I think the name of this activity is also timely kept on the Bhujal Dohan or the groundwater exploitation. Okay. Now, if we further compare this groundwater with the surface water's counterpart, in the first one is extent. I already told you that groundwater extend over a very large area than the surface water. So it means if there are some requirement at places where there is no surface water bodies or there is no supply line, for example, let's say where the households or the dwellings are scattered, particularly in the northeastern part of the country or in the other part of the world, where the households are not, in the larger settlements are not there. In that case, we cannot ensure the fresh water supply from the surface water systems. In those type of these households, the groundwater is the most reliable thing where we can accept it at the place where it is needed. Availability, groundwater exploitation, the exploitation of the groundwater needs energy indeed. Surface water is easily available. For example, surface water, we can tap it from the reservoirs or the lakes, but the groundwater, we need to drill the water, and then we have to bring it from the subsurface to the surface. So that is going to be requiring some energy. Temperature, very important parameter. When you compare it, groundwater has nearly constant temperature. If you take the groundwater in the summer, you can see that temperature is going to be low. In the winter, the temperature is going to be warm. It means that is not susceptible to the climate change. So surface water body, the temperature fluctuates quite significantly seasonally. But in groundwater, the temperature remains fairly constant. And that's the reason that most of the industry, they love to extract groundwater, because they keep extracting the groundwater that is coming at a constant temperature. The time of residence. Time of residence is the time where the water remains in a particular system. Okay. As I told you, the time of residence for the river is 17.4 days. Time of residence in most of the surface water bodies is very, very small, limited. But the time of residence for the groundwater resources is quite high. If you are at a shallow depth, maybe in unconfined aquifer, the time of residence may be even few days to few months. But if you go more deeper, the time of residence is going to be in years. If you go further deeper, the time of residence is going to be in decades or centuries. There's a recent example in Saudi Arabia. There was a well that, and the groundwater of more than 20,000 age has been found. Now you must be wondering that why I'm telling this age and all. The time of residence is very, very important phenomena when it comes to the quality of the water resources. More is the time of residence in the system, more the time of opportunity to improve the water quality is going to be there. So if the time of residence is high in the system, the water quality is going to be also better. So more time of residence is always better for getting a safer water. Susceptibility. Surface water is always susceptible to climate change. If there is extreme events, you can see the surface water impacted. If there's a drought, you see the surface water depleted. If there's some pollution, some spillage, surface waters get contaminated very easily. Okay. So it is very susceptible to contamination as well as susceptible to climate change. However, groundwater, polluting the groundwater or impacting the groundwater by climate change is very difficult. But at the same time, once your groundwater sources is polluted, its decontamination is extremely difficult. In the morning session, I was in the BIS standards committee meeting. It was going on in Delhi. So we were discussing about that is there any standard where we can use the treated wastewater for recharging our aquifers. So this is going to be very, very disastrous if without analyzing the recharging surface water for groundwater rejuvenation. Because having any kind of contaminant in the surface water can pollute the aquifer. And once our aquifers are polluted, its cleaning is, believe me, is very difficult. We cannot clean them like what we do in the surface water body. So we have to be very careful when we make especially these recharging structures. So whatever the source of the water, its quality check is very crucial for keeping our groundwater sources safer. Okay. Projects indeed, groundwater projects are usually single purpose. If a farmer is going to drill a well, it is for irrigation point of view or maybe for domestic use. Similarly, if industry is using, then they are using it for industrial use. But surface water sources, let's say if somebody is going to make a dam or reservoir, that can be a multiple purpose indeed. Project response. Project response means it is very difficult to get the response in groundwater. Let's say, is there any anthropogenic activity which is taking place at the surface? Then you can predict the response of that activity very easily in the surface water. For example, if you are having a lake system, let's say water body, having 10,000 meter cube of its capacity, you take out 5,000 cubic meter of the water, you can easily quantify, okay, remaining 5,000 cubic meter of the water is left because you have taken the 50% of the water for utilization. But that we cannot do in groundwater because we know the groundwater boundary or the aquifer boundaries are not limited to the area where we are studying. The aquifers are having their different geometry, different characteristics, and quantification of the groundwater resources, assessment of the groundwater resources is not so straightforward as we go for the surface water sources. Similarly, for its quality point of view, you can pollute a surface water sources by putting some substrate or some contaminant. You can predict, okay, the quality of the surface water is going to be that if this is going to happen. But we cannot predict, we cannot quantify again the pollution level also in groundwater by doing these anthropogenic activity so straightforward. The quality, groundwater quality is in general, I am saying, better or free from the waterborne pathogenic organisms such as malaria and all waterborne diseases, unless contaminated externally by putting polluted water into the subsurface, because the time of residence is going to be high. Okay. So now if you look at the problems which are associated with the groundwater, so there are 4 types of the problems which we deal with the groundwater sources. The first one is the groundwater depletion. Groundwater depletion means we extract the more groundwater than its natural recharge. So what would happen? Groundwater table will go down. Naturally, if there is no extraordinary extraction, then what happens during the monsoon period, groundwater get recharged, and during the non-rainy season, groundwater declines. But next year again, whenever there is a rain, groundwater is recharged and coming back. So this is the dynamic water sources. If this equilibrium is maintained between the incoming flux in form of the infiltration or the extraction of the groundwater, then we can say, okay, our groundwater is sustainable, it's fine, safer. But when the extraction becomes much higher, then its natural recharge, which is taking place from the surface, then you expect that groundwater will deplete. Maybe after 5 years, it will keep declining. So the trend of groundwater table is keep going down and down. So that is what we can call groundwater mining or groundwater overload. Opposite to that, if there is no recharge, then its extraction, there may be condition where the water low conditions are right. Water low conditions happens when the groundwater level comes near to the surface or above to the surface, then that is the water low condition, and that is not favorable for the environment as well as for the agriculture production or any other thing. We are dealing many water low conditions, even nearby to the road key, and if you go at many places, like especially where the surface water supply through the canals and all, where the recharge is lots of, but then extraction is very limited. In that case, the groundwater waterlogging conditions has been observed. And removal, or you can say the remedial of these type of the waterlogging condition is very important to keep the agriculture or the area of that the problematic sites and the conditions. The second problem, so this was the one is the water extraction, overdraft, second was the waterlog, and the third problem which we are facing with the water sources is the groundwater pollution, contamination. Now, contamination I categorize in two parts. One is going to be because of the contamination because of the salinity. Because if you look at the country, we are having vast coastal area. So saline water intrusion, salt water intrusion is one of the major, you can say, the region where our groundwater has been contaminated, groundwater has been polluted by the high salt. Not only in the coastal region, but in the inland areas also, groundwater has been found saline, and this salinity keep increasing widely, right? And then the groundwater quality. Quality means pollution by agricultural activity, by putting maybe some insecticide, pesticide, which goes through the return flow, through the Meadows zone, and then ultimately meet to the groundwater table. You might have seen the CGWB has reported, okay, high concentration is most of the groundwater wells. Why this high nitrate concentration? So because of the excess nutrients which we are supplying into agriculture. So whatever the fertilizers, chemical fertilizers we are applying, they are not necessarily going to be taken up by the plants whole. A fraction of that will also go down with the return flow, and that would pollute our groundwater resources. So high nitrate concentration has been observed because of this agriculture and dairy industries. Similarly, the other contamination, like any industrial pollution or any other anthropogenic contaminants, are also responsible for the groundwater pollution. So maybe hydrocarbon, like if you go to any city, you can see all these gasoline station, petrol pump, or maybe a motorbike parts. You can see the guy is cleaning your motorcycle and the vehicle and throwing all this contaminant over the surface. So they are not only polluting the surface water, soil water, but ultimately these contaminants, where their petrol and this gasoline, these sumps are there, storage tanks are there, they are leaking, most of them. The example is like one of the busiest airport is Heathrow Airport. There's a meter, more than 6 or 7 meter depth of the hydrocarbon oil, which is residing over the water table. Sometimes there's accidental spills are there of the crude oils and all. So all these contaminants which are spilled over the surface, they ultimately also passes through this Meadows zone, through the soil, and ultimately meet to our groundwater sources. At the surface, we can understand that, okay, they are constant contact with the atmosphere. Maybe some of they can volatilize, and because of the oxygen availability, degradation of these contaminants is very fast. And after some time, natural biodegradation can happen, and then we see the improved quality of the soil or the surface water sources. But in case of the groundwater, oxygen is not freely available. So anaerobic degradation of these contaminants is going to be very slow. So once the contaminants are get introduced into the subsurface, into the groundwater, their degradation is going to be very, very slow. They are going to be persistent for a longer time. So our groundwater sources are very useful, but once they are polluted, once they are depleted, it is very difficult to revive them. Similarly, the coastal region, you can see earlier, I remember 2 decades ago when I visited Chennai and area, there were loads of hand pumps were there. And they were made for fetching the fresh water in the coastal region. But now all these hand pumps are abandoned. Why they are abandoned? If you operate them, you will see the saline water rather than getting the fresh water. So salt water has taken place the fresh water. So salt water encroachment has been taken place in those areas. Now you can say, so what happened? Let it happen. We will recharge it and we will replace. No, it cannot happen. Because we understand the saline water is having the high density than the fresh water. So if you are having a recharging structure, it would not be able to replace the saline water which has been enclosed in the freshwater zone, which is very susceptible. So 1 meter depth of the decline in the groundwater table can raise the saline water by 40 meter upward direction. So very, very sensitive area zone where the saline and the freshwater interface are there. So with nutshell, I can say that groundwater is very, very indeed precious natural resources and very reliable if I'll compare with the even surface water. At the same time, I must say that both these water resources, 2 water sources, we cannot develop them independently. At most of the time, maybe directly or indirectly, these 2 resources are very well connected. If you have something doing with the surface water, if you are polluting surface water, your groundwater is also going to be impacted. If you are depleting surface water, your groundwater is also going to be impacted. If you are polluting groundwater, ultimately it is going to meet with the surface water with the waste flow somewhere, or maybe by extraction. So, lesson is that both surface and groundwater, if you talk about the sustainable development of both these 2 resources, we have to take into account both surface and groundwater resources together. For example, your groundwater has been depleted and you want to recharge it, and that is what the topic of this activity. So we have to be very careful that how much water we have in our hand which can recharge my groundwater. So you have to quantify that one. Where you are going to, how you are going to get, that is surface water. Second thing is that what the quality of the water which you are diverting into the subsurface. So ultimately, groundwater sources, which is going to play a very crucial role, especially during the extreme events, whether it is droughts or it is the floods, with the light is more reliable. But at the same time, once it is deteriorated, once it is degraded by quality or quantity point of view, its remedial is also equally, you can say, even more difficult as compared to the other natural resources. So thank you so much, and that is what I want to convey from my talk.
Thank you, Bridget, sir.
This is Dr. Varun Desai, sir. Thank you very much, sir, for these remarkable and insightful details on the groundwater resources and its attribute. So this lecture have clearly mentioned about the importance of groundwater resources, and all the fundamentals related to water resource management, groundwater resources are well reflected in this lecture. So we really appreciate your continuous effort and engagement in this event. Thank you very much, sir.
Thank you, thank you, thank you.
So, with this lecture, we come to the end of this event on groundwater depletion in India, causes, implication, and way forward for sustainable practices.
Dr. Varun?
Yes, ma'am.
Just for a few minutes. Sorry to interrupt you. Sorry.
Yes,
Thank
ma'am.
you, Vijay sir. I know today your schedule was very busy. Actually, Dr. Varun, Vijay sir come to the Delhi. From Delhi, he reached to the Roorkee. Then immediately, he come to his office, and from office reach around, I think, sir, 4:30. You reach your office around 4:30.
Yes.
And immediately, sir, joined the team and give the lecture. So thank you so much, sir, for your efforts. And no doubt your lecture is very touching lecture because it is a basic where we give the knowledge about the groundwater, its category, types, pollution. And no doubt nowadays it is right time. If we are saying about the sustainable development, sustainable lifestyle, then the most important thing is to know about the importance of the water, both groundwater and surface water, and it is a high time to do its conservation. So the main theme of this webinar is that this webinar is not just limited up to this platform, online platform. Our efforts become successful when each and every person come to know about the important and start doing its conservation from their homes. Then it comes under the sustainable lifestyle. And your lecture is purely linked with sustainable lifestyle pattern and how we can do the management of the groundwater side by side the surface water sources. Thank you so much, sir. Thank you.
Thank you so much. Thank you so much, Dr. Renu. And it is good to see you, all of you again on this platform. And yeah, good to see Dr. Bandopadhyay as well. I think he's there, but I think he's busy with his some other assignments. Yeah, so thank you all.
Thanks a lot.
Mentor, sir. Mentor, sir.
Yes.
Sir, any concluding remark from your end because Vijay sir is calling you.
No, but you know, this is very fascinating. I was just listening to all the deliberations, and it's very fascinating deliberations, and the way, you know, the water, aquifer recharge, surface water, their connectivity, their relationship, and the type of, pollution, contamination. It has highlighted it's really, Professor Bridges, thank you very much. Barun, fascinating lecture. You know, I heard, and it was so good, so nice. And now I must thank you, because you are working deeply, and we are only using your research for our 5 minutes or 10 minutes speech. And you are working deeply on it. And this is the real problem, because somebody very rightly said that there is not going to be any third world war. If the world war takes place, it is going to be a world war of water. And such is the important. And as I mentioned that only, India having such a huge populations and only have 4% of the water resources available, freshwater resources available to us. So that importance of the water, and water not only for drinking purposes, water for everything, water for agriculture, water for industry, water for different types of habitations. So water as a resource is playing a great role, and there is a in total connectivity between the surface water and the groundwater. But unfortunately, due to the erratic behavior of the rainfall, the agriculture sector is just taking away lots of water from the ground. And as a matter of fact, that is causing the aquifer or the water table to go much below. Even in Western UP, sometimes I read the news that the black water was coming out when they were pumping the water. The black water was coming out. So that indicates the amount of water we are extracting from the ground, and that supply is not that high, but the demand is going to be more. So what do we do? How do we mitigate it? And if the aquifer is not charged properly, then there is going to be acute shortage of water even for irrigation. Forget about our drinking water. So these issues needs to be demanded or needs to be looked into for a very highly policy dimensions. So on the one hand, government is giving free electricity. On the other hand, the high capability of the pump set that is coming up. So this is all facilitating the farmers to extract water at a very cheaper cost. But it has a larger environmental costs. So what do we do? That is the most important thing that we need to address to. And I think it's a very fascinating discussion that today we had, starting from 2 o'clock. Now it is going to be, approximately 6 o'clock, 5:50. And I actually enjoying all the deliberations. So thank you very much. Thank you all the speakers. And once again, I must tell as a concluding remark that our Amity Institute of Environmental Studies, I think in terms of organizing such type of events, in terms of working on water and air, and I think it is going to be the force to reckon with as an academic institution to reckon with in these 2-3 areas, whether it's a waste management, solid waste management, liquid waste management, or whether it is for water management, whether it is for air management, whether it is for soil management. Soil management, of course, little work is going on. But other than these 2 areas, 3 areas, the Amity Institute of Environmental Studies is doing immense contribution. I think I pray that they all grow in these directions, in this way, so that they can make their signature very well in the field of academics. And for that, we do need people like Professor Vijay, people like Varun, and other those who are present over here. So their help, cooperation, guidance, collaborations are going to be very, very important. I think we shall all collectively do it. And this serious problem can only be tackled, only be mitigated through collectivism. It is not independent problem. Community engagement, then academicians, collaborative engagement, researchers, collaborative engagements, and then the economists, collaborative engagement that will lead us for mitigating this serious crisis that the world is facing. It is not the only problem of India, but it is a problem of the world. I think, and towards that, I must tell the celebration of this day, as has been announced, we have actually flagged those issues. Now, further research are needed to be done. What do we do in terms of enhancing? Because I could recollect one of the study that was made by, I think I mentioned in some other day, one bureaucrat, Mr. Butch. He has opened his own NGO in Bhopal. So he showed that he planted some trees, and he showed that when the number of trees grew, and the water table, which used to be very low, and water table increased too. So this, forest and its contribution in terms of managing and maintaining that water table has immense importance. So that also needs to be again connected, needs to be again integrated in the whole policy framework. And thank you very much. Thank you once again to all the speakers. Let us keep in touch each other. I think collectively we shall win. Our Chancellor has given the slogan that collectively we shall change the world. So collectively we shall see that how these major problems can be mitigated. Thank you very much.
Sir, today I have submitted my pre-PhD Viva.
Thank you.
Management, sir.
Thank you very much, sir, for your insightful comments on the lectures delivered by today's speakers. So with this, we comes to the end of this event, that is groundwater depletion in India, causes, implication, and way forward for sustainable practices. So a warm and graceful afternoon to our most valued distinguished guests, all dignitaries, head of the institutions, and faculty members from different institutes. At the outset, I, on behalf of the entire fraternity of NRES domain, would like to propose the vote of thanks to all those who have contributed for the successful execution of this event. We are blessed to have with us Honorable Founder President Sir Dr. Ashok Kumar Chauhan, who has always encouraged and inspired all the Amitians. Because of his vision and motivation, Amity University has always achieved new heights of excellence. We are all grateful to you, sir, for your constant motivation and support. I would also like to express our heartfelt gratitude to Honorable Chancellor Sir Dr. Atul Chauhan for his exceptional leadership, guidance, and motivation. We would like to express our gratitude to our Honorable Vice Chancellor Ma'am, who has been our guiding light and a source of continuous inspiration for executing the events. I would like to express my gratitude to Dr. R.P. Ojaswi sir for not only sparing their invaluable time for us to grace this occasion, but also for enlightening us with his commendable talk on this subject. We are also thankful to Professor Brijesh Yadav sir for his thought-provoking key address on groundwater resources. Thank you very much, sir, for sparing your valuable time and efforts for this event. We are also extremely thankful to our distinguished and valued speakers, Dr. Mukesh Anand sir and Dr. Gopal Krishna sir, for their thought-provoking and insightful address. At last, I would like to thank our respected and very learned mentor, sir, Dr. D.K. Bandhopadhyay, respected Head of NRES Domain and Director AI GIRS ASNRSD, Professor S.P. Singh, sir, for leading and inspiring us in working towards the goal of conducting these events. And in future, we are also working to conduct such a successful events from our domain. My sincere thanks to Professor Tanu Jindal ma'am, Group Additional Pro Vice Chancellor. My sincere thanks also to Dr. Randeep Singh, Additional Director AIFW, Dr. Renu Dhupar ma'am, Additional Director AIES, and all other faculty members and staffs of NRES domain for their support and involvement in the successful execution of this event. Above and beyond, I especially thank the people who have been the backbone of the function, the IT team of MIT led by Sodhi sir. We are very much thankful to them for their continuous support for successfully conducting this training workshop. Thank you very much, sir. And on behalf of, at last, on behalf of the entire NRES domain, I personally very much thankful to all the speakers who have given their valuable time for this event. Thank you very much. Thanks to all.